It's a Thursday night. What's up, fellow technicians and people that enjoy watching people repair amplifiers? What's up? Good evening. How is everyone being? 2 minutes late. Oh no. Well, the countdown started at 1:45, so that's not so bad. Yeah, feeling great this evening. Had a mental sleep. Oh my days. My sleep last night was freaking insane. Third era. Thanks very much for the 5, man. First round's on me. Oh, crap. I better grab myself some juicy juice. Yeah, I'll grab that in a minute. Thank you very much, Third Era, for the 5. Awesome. Thank you very much, my man. What's cracking, Mike Honda? Good to see you back in the stream. Good to see you all back here. All these names that I know. Jack the Ripper. What's up, buddy? Fortunately, I wasn't late. Well, depends if you count the countdown as late or not. So, gentlemen, for this evening, as promised last night, we talked about cameras. So, obviously, we have the side cam. Obviously, you have the top cam. This one here. Obviously, got the scope cam. And also got the inspection cam. But also, for this evening, going forward, we also have a cheeky hat cam. How's it going? Welcome back, hat cam. It's been a while. It's been a while since we saw you. So, hopefully this isn't too nauseating, and this makes it a lot easier. I'm not gonna lie, this is a much better view than top-down cams. This is like top-down cam, so I can probably actually use this one to do a zoom. You know, I can use that top cam to zoom in a bit further actually, because this camera is really good for getting up all close on the board, like seeing all right up close on these components. Like, it's got a wicked zoom on it, so I could use that one for nice up close stuff. And I can keep the old hat cam as a kind of movable inspection cam right here. So yeah, we're gonna be rocking the hat cam again this evening. Been a while. Wow, Sean, get some caffeine. Okay, so interestingly, I don't do so great with caffeine. What ends up happening is I guess I'm already quite an excitable kind of, I already have a lot of energy anyway, especially when I'm doing things that I enjoy doing, like amplifier repair. So when I have caffeine, I feel like I'm kind of too, like my brain is ahead of my body, or like I can't do things, it's not quite, I need that balance of kind of serenity, but also the natural kind of, I don't know, spikiness that I have with my brain and the way that I think anyway. Caffeine just kind of makes me feel like a bit too, like, a bit worried about everything, like, fucking hell, what's going on, like, not so great. Mike Honda, my man, 20, rolling in with the 20s, drink on me. Alright, yeah, we'll go and grab some drink in a minute. Too shaky, my vertigo. Yeah, so it is a bit shaky. Obviously, these webcams, These were like 10 bucks each from Facebook Marketplace about 3 years ago when I started doing the live streams. So that's why the quality isn't fantastic from these cameras. Yes, it's a little shaky, my bad. I'll try and keep my head as still as possible when I'm doing the head cams, but it's not too bad. A few people did say that when I started using the head cam a couple of years ago, that it was a bit shaky at times, but we'll see how it goes. See how it goes. Good evening, dude. Evening, Adam. How's it going, my man? Hope you're well. Hope you're not too cold in that workshop. Crack open some heaters in there. I was watching a video earlier with hat cam. Good stuff. Good stuff. Okay, gentlemen. If you saw my video last night, my live stream last night, we cracked open this Hertz amplifier, which is £1,000, which is about 1,300 bucks. This will cost you brand new when it was originally brand new out. Hertz HP1D, and we were looking at why is it £1,000? What makes this amplifier so much more expensive? It's 2.5K RMS at 1 ohm. What makes this amplifier so much more expensive than other 2.5K amplifiers on the market? And we pretty much discovered for the most part that nothing. You're paying for the brand name, you're paying for a fancy screen on the front that tells you voltage and amp temperature, and you're also paying for a slightly faster switching frequency on the output section. You're paying for 200 kilohertz sampling frequency of the sine wave, as opposed to about 125, 150 kilohertz on most other amplifiers. The one thing which I forgot to touch on last night actually is, does this amplifier give you the option to run a bit more full range, like a bit higher frequency? So with the 200 Hertz sampling frequency that we've got in this amplifier, it should be a little bit nicer at producing those punchy kind of mid-bass kicks and stuff like that, you know, a bit higher frequency stuff, because we have that faster switching frequency. Oh man, this amplifier is such good condition. This is such a beautiful condition one. Don't often see amps come in such nice condition here. Most of these amps have been ragged to pieces. If we take a look here, we've got a low pass. Now the low pass is a fixed low pass, and actually, yeah, you know what? Okay, it gets you up to 350 Hertz, which is a little higher. Most of the amplifiers which use this same circuit, the Korean half bridges, well, the low pass takes you up to about 250 Hertz. So, you know, 350 Hertz, that's getting into the realm of lower end vocals. So let's say you had some, I don't know, for example, my T-line doors, yeah, so my T-line doors in my car, I start sloping them off at 200 Hertz. So this amplifier, if I wanted to throw 2.5K at them, then I could with this amplifier, given that 300 Hertz roll off on the low pass. This wire is going to drive me freaking nuts. We have to deal with that. So yeah, essentially that's not a bad thing. That's pretty cool. And that higher switching frequency, that higher sampling rate with the Class D switching frequency will aid in getting you nicer sounds when you're playing up there. What did I used to do last time? How did I used to have the hat cam last time so it wasn't driving me nuts with the wire? Did I like tape it onto the side or something? I can't remember. Tape the wire around the peak of your hat, like. Yeah, maybe the problem is the wire's not so long. It's plugged into the USB just down there. So if I start taping it up, I get less length. I could probably tape it there actually. That's probably a good shout. Hey, let's grab some Tessa tape. Let's just quickly do some hat repairs first. I think Tessa tape should hold it onto the hat material. Let's see. Let's go there. Let's tape you onto there like that, my friend. Keeping in the black theme. I don't think it holds that great. Yeah. Oh, that's better. That's much better. Straighten her up. There we go. Nice. All right. Yeah, absolutely. Absolutely. He should tuck the hat cam behind his ear. Oh, that's not a bad idea. Actually, I could have whacked it behind my ear, couldn't I? Yeah, that would have been a good idea. Around my neck. Yep. Could do that as well. 30 volt RMS hat. Yeah, alright, cool. So, anyway, based on last night's live stream, we discovered that this amplifier works okay. It comes on, have output switching, but we have a really disgusting looking sine wave coming from the output section. If anyone missed last night, then let's show you guys what the sine wave looks like coming out of this amplifier. First of all, just going to plug the wires back in. I need to get my, grab my big old chunky Allen keys to get them in. I should probably, like, when I get my new workshop, one thing that I'm going to do is I'm going to set myself out a nice little row of Allen keys that are commonly used for different amplifiers, and I can just like grab the right one that I need, because a bunch of these are all way too big. There we go, that'll do. Yeah, my floor is a mess, bro. This is a workshop, innit? So I don't really get a great deal of chance to, you know, tidy and clean up and stuff. Matthew, cheers for the 2, buddy. Thank you very much. Saw you made your good old JBL sub into a test one. Yes, I did. Absolutely. That's been my test woofer now for a couple of years, and it's held up to some serious free air abuse. I'll give you that much. So let's see then what's the problem with this amplifier. If you weren't there last night, we're going to check out the shape of the sine wave again, and we're going to work out why it's doing that. So let's give you the scope screen. So when we turn this amplifier on, and we are going to feed it with 55 Hertz sine wave. We've got 10 volts going in and 4 amps here. Yeah, let's turn it on, get it up and running. Let's go to 10 volts divide and 5 milliseconds on the scope. Probe the output speaker terminal here. Whoa! Look at that bad boy. Look at that bad boy wave. How's about that? Not so tasty. So that's what we're dealing with here. This is what we're going to try and figure out and fix. When we look at the output section itself, when we look at the output fets, we do have really good switching. So it's not a drive circuit fault. The drive circuit appears to be just fine. Let's go in over here before the inductor. Where am I? Here we go. So yeah, this is the output drive. So it looks great. Again, as you can see there, got about 194 kilohertz. It's a little bit more slopey. This amplifier is a little bit more slopey on the switching wave than most that you might be used to seeing. If we take a look at the wave just after the gate resistor for the low side, you can see why it is a bit more smooth and slopey. So what Hertz have gone for here is they have gone for slightly softer switching of the MOSFETs here. So I imagine, I'll check the resistance in a minute, but because we have a slightly faster frequency, a slightly faster switching frequency, the drive never looks as clean anyway because it's turning on and off quicker. But the gate resistor value here, I believe, is reasonably high. So we get a kind of a slow turn on, like a kind of ramped turn on, because this MOSFET gate is charging here. See this little spike here, just as this turns on. This spike is the MOSFET's threshold. So this is the point when the gate suddenly turns the FET on, and there's a little dip there, a little bounce, just where the FET turns on and kind of like boom, you know, like a little boom, it's turning on. Whoa, okay, now we're on. So the MOSFET is on for the whole duration here, and then the MOSFET turns off, and actually the drive drains quite slowly out of the gate leg here. So the pull down isn't particularly fast. And there's another little bump here, little boop there where the MOSFET is turning off. So the MOSFET turns off, get another little boop there where it turns off, and then we're back down to 0 volts here while the other side is switching. So yeah, we've got a relatively sort of soft drive, which is what gives us that slightly smoother looking output sort of drain wave there. So yeah, that all looks good. We don't have any drive issues in the output section. So what we need to do is we need to follow our 55 Hertz through the board and figure out where it gets its janky shape from. Is it a preamplifier issue, or is it part of the pulse generation circuit that's causing the issue? So the first thing that we're going to do here, the first thing that I recommend you guys do if you've got a similar situation where the amplifier seems to come on and switch fine, but the audio looks bad, is take a look, try and figure out where is your drive circuit, where is your output section drive circuit. So it's quite obvious on this amplifier, it's nice and easy to see. We've got the driver board right here. which is the drive circuit for this amplifier. So this drive circuit here will have a pin which has the final processed audio wave on it, ready for converting into pulses. So on one of these pins, probably one of the middle ones in here, there will be a sine wave. There'll be the input from the preamp section. So what we want to do is we want to have a look, probe each of these, see which one is the audio input, and see what shape it is. Because if it looks like a nice clean sine wave going into the drive circuit, then we know that the issue is happening somewhere in the pulse generation circuit. If it is a janky looking sine wave, like we saw a minute ago on the outputs going in, then we know that the issue is somewhere in the preamplifier section. So yeah. It's a spike the gate capacitance. Yeah, sort of. So the spike is the FET turning on and off. Yeah, that causes like a little ripple. You know, like, try and think of a similar kind of instance. You know, when you turn something on, you get like a or something, or when you sort of when you turn an engine on, or when you turn a motor on, you get like a spike, like a before it like smooths out. It's just a little spike at the start. Snipex, what's going on, buddy? How's it going? So let's get the sine wave playing then, and let's probe the input pins of this driver board and see if we can find out why there is bad audio. Is it going into the drive circuit, or is it somewhere after that? So let's take a look. I'll give you this camera actually, I think, and let's go over here so you can see me probing the drive circuit. So it's dead straight on, so you can't quite see what pin I'm probing, but you should be able to see a bit easier on the scope screen here. So let's get her fired up. Let's get her railed up here. Amplifiers come to life, output switching is active, and we want to turn the scope settings to 5 milliseconds, reject high frequency. We want to go right down to about 2 volts divide, maybe even 1 volt divide. The audio input wave is very, very low amplitude coming into the driver board here. So nope, it's not that pin. That's a bunch of PWM. It's not that pin. That's DC. That is 0.6 of a volt, so it could be that one. I haven't turned the gain up that much yet. Now we have this one, which is also 6 millivolts. That could be ground. Then we have negative voltage, and we have negative voltage. Okay, so let's turn the gain up a touch more until we get that wave on the outputs that looks bad. There we go. Okay, cool. So now we've got the wave on the output terminals that looks bad. So let's see if we can find that same looking wave on the driver board here. Okay, interesting. I don't actually see it, you know. Maybe it's on some DC. Or it could actually be coupled to this this PWM here. I've seen that done a few times. So it's not this one. This is +5. That's the 5 volts VCC. This here appears to be ground. Ground is 6 volts on this amplifier for some reason, reference to my scope. That is also ground. That here is negative 4.4. And that is probably negative, what's that, negative rail. That's going to be negative rail, yeah, -50. Interesting. So where is our sine wave input then? It's going to be one of these pins. It's going to be one of these pins. There's no doubt about it. Just why can't we see it? Okay, the gain is now maxed out on my signal generator here. Absolutely maxed out the gain. So now let's zoom back in and see if we can see this wave. Okay, I've got a feeling that the way that this amplifier works is you see this PWM, which is right here. This PWM, I think that the sine wave actually is inputted into this, and the driver card outputs PWM kind of to oppose it, and that's kind of how it works. So I think that could be the issue. I think that may be where the audio is coming from. So we haven't managed to find a clean version of the audio wave that's on output on the input pins of the driver card. So what I'm going to do now is just go back. I'm just going to go back a little bit into the circuit here. I'm going to have a look at the driver board, sorry, preamplifier board. So here we have the preamp board, and there will be some pins on the preamp board that are the outputs of the audio sine wave. I don't know which ones they are. There's a whole bunch of pins around here. So what we're going to do is we are going to probe some of the output pins until we see something that resembles either a sine wave or something that resembles the kind of janky wave that we are normally looking at. Okay. So nothing on here. Let's keep looking. Aha, there's something here. Let's have a look. What do we have here then, my friends? Okay, if we go to 5 milliseconds and we zoom right in. Oh, okay. There is something there that looks like it's kind of similar in shape to what we're looking at on the outputs. So very, very small, very, very low amplitude, but that looks like the similar kind of thing that we've got on the outputs, just as a very small version. So I think the issue is going to be in the preamp section. Let's keep going and let's look for a output that looks pretty bad. DC, nope. Ground. That looks like it could be an output. Ah, what's that? What is that? Ugh. Okay. Well, that's definitely something. Look at that. So that is what appears to be 12 volts DC. We've got 11.42 there. And as I turn the gain up, we get the bottom half of the sine wave start riding along that DC there. If I do auto level trigger, then we can see it there. What on earth? All right. So let's keep going. Let's keep going along these pins and see what else we find. Okay. Yeah. Oh wow! Look at that. We have the top half of the sine wave riding along the negative 9 volts. What the fuck? Wow. Okay. So this is clearly a preamplifier issue then. Clearly a preamplifier issue. Alright, let's try the other side of pins. That's plus 5 volts. That's plus 12. That's minus 12. Ah, there we go. There's our sine wave on the bottom half of the sine wave. On the negative there. And do we have the positive half of it? No, we don't have the positive half of it over here. So yeah, definitely a preamplifier fault. Okay, cool. Fun times. Not seen that before. Now, because this is a preamp fault, there is one common fault that you tend to find sometimes with preamplifier sections, and it can be very, very simple. So what we're going to do is we're just going to take a flathead screwdriver and we're just going to take off the front plate of this little plate here. There we go. I think that screw is meant to stay in there and I wasn't supposed to screw it out all the way. Oh my goodness, dude. Holy crap. DL Carburetor, love your approach to improving the world by fixing things. Listening but won't be able to see for about an hour after this message. I'll be back. Man, holy crap. Thank you for the 50. Jesus Christ, dude. That's amazing. Like I say, if you've got any personal questions, man, just shoot me a message. Happy to help you out. That's freaking awesome. Holy crap. Thank you very much, my man. Thank you very much from the bottom of my heart. That's crazy. Don't forget to remove the GoPro should you go to the restroom. Yes, absolutely. I have done that so many times. When I had the hat cam before a few years ago, so many times I'd like get up and I'd be like hat would be pulled off my head. So yeah, with the preamplifier circuit then, here we have 5 potentiometers, but there's also 3 switches. Okay, now when you've got issues with audio output, but the output section seems fine, this is the first thing that you should always check. These switches, especially if they are not moved in a long time, oxidization builds up on the contact kind of rails in the switches themselves. And what happens is it doesn't make a proper connection. The audio wave actually travels through these switches. So if it's like making half a connection or a poor connection or something, it can actually make all sorts of weird things happen, similar to what we're seeing here. Like half of the wave appears and the other half doesn't, or it makes a distorted output wave, or just or DC on the outputs. Even DC on the outputs can be caused by this. So very, very strange things can happen from this. Now, I have run. Now, what I normally suggest you do is you spray 99% isopropyl alcohol into there. I haven't got any of the new stuff yet. So what we're going to do is we are going to use, now what I have some 70% isopropyl alcohol that's kind of somewhat reasonably conductive, but I also have, which you can substitute in, some men's aftershave, which is ever so slightly conductive while it's wet. When it evaporates away, the conductivity disappears. Now, because we're looking at low voltage here, audio waves and etc. with the switches, you can, in a pinch, use some aftershave or even perfume or something like that. It's pretty high in alcohol content. It's actually higher than the 70% isopropyl that I've got here, which is kind of strange. So we've got a choice. We can either use the 70% or the aftershave. I measured a higher resistance on the aftershave, so we're going to go for the aftershave this evening and do that. So let's take the aftershave. We're going to spray it into each of these switches here, like so. I'm going to flick them back and forth multiple times. Get it all cleaned up in there. It does, it smells great as well. Like, the customer gets their amplifier back and they're like, smells good. Stank. Carla says, Sam, I use cake deoxit for that issue. It's perfect. Yeah, absolutely. There's plenty of really good solutions that you can use for this. Aftershave is not one of the best, but this is what I've got on hand at the moment, unfortunately. As you know, isopropyl alcohol is kind of hard to get at the moment in the world that we're in. It's very high demand. There is some that's available. I just need to go ahead and pull the trigger on ordering a new bunch of it. But I keep forgetting. You know, when I go upstairs and go to sleep next day, my mind's on other things. I keep fucking hell, I need to order isopropyl alcohol. Mr. Sweet, I can't believe how many streams you've been doing lately. Keep them coming. Yes, my friend. We are streaming every single day in December for what I call STREAMMAS. It's not Vlogmas. You might have seen other sites do, or other channels do Vlogmas. I'm doing STREAMMAS. Okay, cool. So I think that's probably about enough on most of these, just to kind of see if that's made a difference. I don't have the highest of hopes as to whether this made a difference. The audio wave we're seeing on the output, that kind of says more to me like we've got a leaking or a faulty op amp. But this is the first thing that you should always do if you've got kind of audio issues, especially if you've got switches on the amplifier here. So let's put this back in the right position. We've got output phase normal, subsonic. Actually, let's turn everything off. Just see if that makes a difference. So let's turn subsonic off. Let's turn the high pass off. Actually, you know what? I'm pretty sure the high pass was... No, the high pass, was it on or was it full? I don't know, I can't remember. But let's go for full frequency range on there. 50 Hertz boost off. Low pass, let's crank that to... actually, you know what? Let's crank low pass up a bit. Let's just get low pass turned up a bit. And then level, let's turn the gain up a touch so I don't have to put so much signal in from my signal generator. There we go. So let's see if that's made any difference. I don't have massively high hopes. I think this is another issue with an op amp or something, but let's see. Let's see how we get on. How is your car? Did you get your iron working yet? Car is okay. It's at a garage. It's having a smaller belt put on without the second alternator in, which is cool. And we are also... the iron, it hasn't arrived yet. I had to order the iron tip from overseas, so it's gonna get here between the 12th and 15th of December, apparently. So hopefully we'll get that pretty soon. But I do have some irons, and I've got my hot air station, which I'm pretty competent with. That I can desolder most things with anyway. So yeah, it's not the end of the world. It's just a little bit annoying. All right then, let's turn it back on and see if that has changed what the sine wave looks like on the output then. The remote has fallen out. Let's plug that back in. I don't think this has made a difference. Nope. Okay, same old junk. Okay then, so this is definitely an actual, electronic component issue then. So, fortunately for me, this amplifier actually has the actually has the preamplifier board as a kind of separate module. Most of the preamplifier board is actually on this kind of separate board here. So what I can do is I can go ahead and unscrew this, and we can remove it from the amplifier without having to take the whole amp out of the case, which is wonderful because this amp is a nightmare to get out of its case. So let's pull this preamp board out and start testing. However, the fact that this is on the board like this means it's kind of annoying though, because we can't really test or probe any of the op amps while it's in the board. What we have to do is we'll have to kind of unscrew this, we'll have to take a mental image of where all the op amps and parts are, and then we'll have to kind of put it back in the board again and probe from the underneath. I hope they're not surface mount, because we won't be able to probe them if they're surface mount, because they're kind of facing the wrong way there. So in order to get the rest of that out, we have to turn her over and we have to take these knobs off. These can be a pain in the butt to get off, and you can obviously pry them off with a flathead, but that can damage this brushed aluminium sticker here. So I just want to try and get under here with my fingers if I can. If not, then the second option is to grab some tweezers, and you can kind of go either side of them, which prevents damaging the aluminium so much, and just sort of start pulling up like this. Hopefully they'll start coming out. I'm sure there are some like proper tools you can use for this. Maybe some plastic tweezers. You can get under there with some plastic boys without snapping the plastic tweezers. There we go. I think it's starting to come up now. That's one. Looks good. Do you have any trim removal tools? Trim removal tools. Oh, they're like the little the blue plastic things. Yeah, I've got some of those somewhere. I've got some of those upstairs for like Nintendo Switches and stuff like that. But yeah, they're all the way upstairs, which is like 4 floors away. Bing. Bing. So now this preamplifier board will just come out nice and easy. Okay, so what do we have here then? We have a bunch of surface mount components, which is a little pain in the butt, because being surface mount and the way that this mounts down in the PCB, you can't actually probe them while the amplifier is up and running. I would have to grab myself some kind of extenders for these, so that I could then rest this board separately out of the circuit. So that's a bit of a pain in the bottom. But what do we have on here? We have a bunch of 072Cs. So we've got 072C, 072C. We've got 1, 2, 3, 4, 5, 6 072Cs. We have a couple of film capacitors over here, which look like an afterthought. They look like a modification that was made to this amplifier at factory, perhaps to improve the quality a little bit or something. So with the board out of the heatsink, then one thing that I tell you what, one test that might be good that we can do is we can power the amplifier up without this board in, because this board is obviously going to be secondary. So we've got the RCA coming in here to the amplifier. This is then going to go through some basic preamp sort of buffer first before it gets to this filter board here. So what I want to do is I want to see whether the bad audio signal is present on the inputs to these already, before it even passes through this board, because otherwise there's no point working on this board. This board is probably going to be fine. I do actually have the added benefit of having 2 of these amplifiers to work on. This Hertz amplifier, I've got 2 of them to work on, so the chances of both of them having the same fault is quite a small chance. So I could go and grab the other Hertz and literally just blind swap these boards out and see if that makes a difference, and if it does, then I know that the issue's on here. That's like a nice easy kind of shortcut, if you like, to figuring out where the fault is. But you know what, let's leave it. Let's pretend that we only have this amplifier here. Let's talk you through what I would do if I only had this amplifier here. So hopefully my oscilloscope probe fits into these holes. Yeah, just about. It's a little tight, but it does just about fit into these headers. So we can look for the audio wave going in here. So let's turn the amplifier back on then. Let's look for the bad audio wave going in to the filter board. That's the next thing we want to do. Let's power her up. Okay, so without the filter board in, obviously we have nothing on the outputs of the amplifier, which is as we'd expect, because we have no audio going into the driver board, so that's cool. So now let's start probing and looking for jankiness on the inputs then to this filter board. So first one, let's turn auto level off because it kind of makes a bit of a delay, it's kind of annoying. So let's go right down to 2 volts divide. Let's start probing. Okay, there's our 5 volts. Nope, that appears to be ground. Next one. That also appears to be ground. That appears to be 0.5 of a volt. I'm just twiddling the knob as well of my frequency generator here just to see if the DC changes on any of these pins. Because if the DC changes as I go up and down with the input level, then you know that could mean something as well. Here we have okay, so here we have the same issue. So we have what looks like 11.6 volts, and we have that audio riding along it, and then the same for this as well down here. Okay, so I believe then that the issue is obviously going to be before the filter board, so swapping out the filter boards won't make a difference in this case. Alright then, cool, well that's got us somewhere. Now let's take a look at what is before the filter board. We want to be probably looking at like op amps and stuff. So over here we have, this is the PIC for this front board, don't need to touch that. Here we have a 74HC595. Now I wonder whether that's got anything to do with it. That looks like it may have been soldered at some point before. See, that looks like it may have been soldered at some point. Let's have a look and see what we've got going on with this 74HC595. I'm going to probe the pins of that because that generally has some sort of PWM and sine waves on it. So let's give you the scope screen. Let's see what we've got on each of the pins of this chip. So we're going to start from pin number 1. Pin number 1, 0 volts. Pin number 2 has 4 point. Oh, hang on. What does pin number 4 have on it? Is that moving or is that just my probe? No, pin number 4. Pin number 2, sorry, is jumping around all over the place. Got some little sort of PWM spikes there. Okay. Pin number 3 is nothing. Pin number 4, nothing. Pin 5, we have 5 volts. Pin number 6, we have nothing. Pin number 7, 5 volts. Pin number 8, nothing. 9. Okay, 9 we have some kind of spiky PWM as well. It's kind of like coming and going. That's definitely not right, is it? I'm sure that's not right. Unless this has something to do with the screen. 5 volts. There's some kind of spiky data as well. This could actually have something to do with the screens. This might not be anything audio related, but I'm just curious to see what we have on here, because this does look like it's been desoldered before. Okay, that's on pin number 6. Okay. So strange happenings on the 74HC, but I don't quite know yet whether that actually has anything to do with the audio or whether it's just to do with the screen there. It could be what that could be. That could be giving data into this PIC, like about temperature and about input voltage and stuff like that. So let's keep looking. What I want to look for is an audio wave coming off of an op amp. Like, so for example, these two here. Here we have some TL74C op amps, so those are most likely going to have the audio on them coming in from the RCA. So let's take a look at those and see whether we have clean audio going in there. You know what, we actually don't. We actually have what look like some kind of similar looking spiky boys on that one. Okay, here we go. Here's something. So that looks like a pretty clipped wave there, doesn't it? But that's just probably just because my gain's up so high. So if we back off the gain a little bit, look, there. We only have like a little bit of a sine wave. Okay, so we're getting there. We're getting there. We're getting there. So what we're looking for is we're looking for somewhere that has a clean wave going in. That shouldn't be there. Okay, guys, we have the sine wave riding along negative 5 volts on this TL074. That shouldn't be there. That should not be riding along DC. So we're finding the problem here. Now we just need to find out where's that 5 volts of DC coming from. So we've got 5 volts DC on every single side of this TL074. We've also got pretty much 10 volts there. Minus 4.4 there. We definitely shouldn't have negative voltage on any of these. So that is not right. Over on this one, over on this TL074C, the second one, which is just above it, we got a nice clean sine wave on there. Alright guys, we have, I believe, filtered out the issue, and I reckon that the faulty component is probably going to be this op amp here, this TL074CN. I imagine that's going to be our issue, because the one above it has clean audio on it with no DC, and the one just below it has the DC on the audio signal and those kind of strange looking half waves on there. Now, another thing that you can sometimes do to find bad op amps is they usually run a bit hotter because they're kind of leaking or shorting inside. So if you've got a thermal imaging camera, you might be able to pick out a bad op amp just by seeing which ones are heating up more than others. So I'm going to take our thermal imaging camera right now and see whether that is actually the case. See if we can see whether... Oh yes, okay, that looks like it might actually be getting pretty hot compared to the other one. Let's turn the amplifier back on. And let's give you the thermal imaging camera ruby here. So, I mean, there's definitely a hot spot over here. We've got 32, 33 degrees over here, just where these op amps are. If we look at the rest of the board, we have other bits on the board over here which are heating up, 30 degrees. So, okay, maybe not really getting that hot. 30 degrees isn't really that bad. You know, that could be a normal operating temperature for an op amp. We're now up at 39 degrees, 40 degrees. Yeah, that's not really like crazy. Often you might see like 60 or 70 degrees if it's really bad. Let's turn it off and let's see if I can feel if any of them are hot with, you know, to the touch here. Neither of them feel hotter than the other, to be honest. But yeah, so my guess is then that it's probably this bottom one that's bad. Let's just check the other side of this top op amp. Ah, okay, hang on a minute. No. The other side of this top op amp actually has DC on it as well, minus 9 volts. You know what? The best thing to do is probably just to replace both of these. The thing to do is probably just to replace both of these 074Cs. Because they both seem to have DC where they shouldn't be. Alright, cool. Well, let's crack on with that then. Fortunately, I can do that from the top of the board with my hot air gun. Yeah, these are really common ICs. I should have a bunch of spare ones of these already. Let's have a quick look, see what I got in here. This is my little crate of TL494s, but from memory, I think once upon a time I accidentally dropped in some 074Cs into here, so we might find some 074Cs in here. We also might not. Let's have a look. See what we got. TL494. Let's turn my hot air gun. Let's get that cranked up with the temperature. There we are. There we go, there's one. TL074C. Just need one more. TL074C, there we go. Just see if there's a third one, just in case. In case we need a third for whatever reason. There we go, there's another one. Alright, awesome. And these are all brand new, are they? All the same batch. Looks good. Okay, cool. Let's see what you guys are saying. Yep, preamp fault. You all nailed it. Preamp fault. Yep, absolutely. What's up, John? Good day from Australia. Good day from the UK, my friend. How do I send my amp to you? I don't really take amplifiers from overseas, so if you're in the UK, then great. Just send me a message. Let me know you're in the UK. But if you're not, then the shipping just costs too much. It's not worth it. Tom, what's up, my man? Good evening. How's it going? Yes, Michael, it could be a leaky surface mount cap that is not blocking DC. You're right, it could be. But the most likely thing that happens with these is that it's a faulty op amp. So we're going to start off by replacing the op amps and seeing what kind of difference that makes. So let's grab some solder flux. Whack a bunch of solder flux in there. Let's try and get this in the camera view on this one so you don't have my shaky head all the time. There we go. So you can kind of see what I'm doing over here. Let's just run a little bit of flux along these legs to help the original solder melt there. Now, one thing I do need to be slightly careful of is that these boards, they do popcorn. And popcorning is when you heat a certain part of the PCB and the air in the layers of the PCB expands and it causes bubbles in the board, which is not what you want. So what I'm going to do is I'm actually going to preheat the general area with the big hot air gun first a little bit, just to kind of try and prevent that from, you know, potentially causing a problem. You have shaky hands. I don't have shaky hands. Look at this. Look at this. It's nice and steady. I'm also quite excitable. But yeah, I have pretty steady hands. I can do really tiny surface mount stuff pretty well with the Nintendo Switches and that. I wouldn't say that's too shaky. I'm sure that at one point in my life, that, you know, when I'm old, I'll be all like this, because that happens to the best of us, unfortunately. So we'll have to wait and see. Yo, H1 Nicholas, how's it going, my man? Good to see you here. How have you been? Yes, PCB blistering is probably the correct term, as opposed to popcorning, as I called it. Okay, that should be warm enough just to get these out of here. Now these are very close to each other, so what I'm probably going to do is I'm going to go in from the side, just underneath, and just hold a little pressure underneath here, just while these heat up, and it should kind of pull one side out a little bit. There we go. I can feel her starting to come up. There we go. There we go. There we go. Okay. There we go. Starting to come up nicely. Now I want to try and get in under the other side, but that is very tight in there to the other one. Let's see. I just want to bring it up a touch, just to try and grab the edge of it there. Going from the other side again. Let's just try and lift it up in one go from this side. I've pretty much got right under there now. It's tricky, you can't really see that, it's in the way. I've pretty much got right under there now, so let's try and lift her up in one go. The board is very hot, so my hands are slightly too warm right now. Come on. I suppose it doesn't really matter if I bend the legs actually here, because you know, we're getting rid of this one anyway. There we go. There we go. That's fine. Bent the legs a little bit, but I'm not too bothered about that because we're replacing it anyway. So that's one, and then number two. There we go, awesome stuff. Both of those removed nice and cleanly. Use the same amount of flux as Lewis. As wait, is it Louis? Louis. I can't remember if you pronounce it Lewis or Louis. I used a very small amount of flux just then. I'm pretty sure he uses like a bucket load of flux. I'm pretty sure I use a small amount. This flux is freaking awesome, guys. If you're looking for flux, this is the best stuff that I've ever used. Chip Quick SMD 2913 0cc. Yo, Hayes, what's good, my man? Glad you went back to the camera on your hat. Yeah, it's definitely a pretty cool hat, isn't it? Pretty cool idea. Pretty cool. Louis Rossman. I think it's Louis Rossman. I think that's how you say it. He puts bucket loads. Yeah, he does. Okay, cool. Now to suck the solder from these holes, I'm gonna have to use the fine tip here because my normal tip that I use is still waiting for that to arrive from overseas. So we're gonna have to see if this fine tip's gonna work. But this fine tip is so rubbish because it has such a low thermal mass. It takes forever to heat up each of these. But fortunately, because it's a point, I can actually get right in there. I can kind of put the tip right into the hole, which is quite nice. Which heats it up all nicely, and then remove it, suck it. I do prefer using my my wedge tip. If that's the correct term. Technically, I don't really need to be desoldering the holes here. I could just use my hot air and drop the new chips in with the solder melted, but I worry because I would have to heat up the board so much. Like the board would be really, really hot while I'm doing that to get all of the holes melted enough that the legs will just kind of go in there nicely. So sucking the holes here is the safer thing to do, even if it takes a little longer. Why don't you use solder wick? I would use solder wick, but in order for solder wick to work nicely, I need like a wedge tip, soldering iron tip, which I haven't got at the moment because they all broke and they were out of stock, so I've had to ship one over from overseas. So the only soldering tip that I've got is this really sharp one, and this isn't going to work so great with soldering tip wick, because with soldering wick you need like a tip with a decent surface area to actually get heat into the wick for the wick to start working. So in this scenario, it's better if I just use the tip like this and kind of push the tip into the hole, into the solder joint, and then it kind of now I can kind of push it in, and the heat just kind of fills around the via. It is a bit long-winded compared to doing it properly, but I don't have the right soldering iron tip at present, unfortunately, so I'm just having to do it like this for you guys this evening. So you guys loving the head cam, but what did you guys think about the soldering iron cam, the iron cam? I only had that probably for about a few streams, because it did start falling off. Obviously, I duct taped it on, so it was just a kind of quick experiment, really. So I just duct taped it on really quick to see how it would look. and it looks pretty cool, but obviously the duct tape melted with the heat from the soldering iron, so it didn't last long. But if I get myself a really tiny USB camera, like a really small one, I can sort of CA glue so it doesn't get in the way so much, then that might be pretty cool. So if you'd like to see a soldering iron cam in the future, let me know, because I think that might look really cool. What brand soldering iron do you need tips for? It's AOUA. It's one of these cheap AOUA stations. Yeah. I have ordered one, but it's meant to get here, I think, on the 15th, so I've got another 5 days worth of streams without it. This is really annoying. This is working just painfully slowly. It's painfully slowly. If I had my proper tip, this would have been done like ages ago. There's so little thermal mass in this tip. Okay, that's one done and dusted. Need to clean it up a bit, but let's move on to number 2. What I'm going to do is I'm going to use my hot air gun just to kind of heat up the board a little bit around this area to make it a bit easier for me with the iron. Weber, hey Sam, I got off work early so I could come and join your stream. Holy crap, man, that's dedication. Appreciate that. That's awesome. I hope that they were okay with that. That's awesome, man. Good job. Thank you. Come on, heat up. Come on. I don't want to end up breaking this tip as well, but just by putting pressure on it. Yay! There we go. Finally, she's in the hole. That's what she said. There we go. About time too. Oh, this is so painful. This is so painful. I imagine this is painful to watch as well. Maybe I can do this with hot air instead. Can I do this with hot air instead? Make my life a lot easier. Oh yes, the hot air works. Oh, that's so much faster. Literally got like 2 at once then. 2 for the price of 1. Buy one, get one free. Do you repair other electronics or just car amps? So mostly car amplifiers. You know, I'll repair other stuff around the house if I need to, but I don't offer that as a service to anyone. Home amplifiers, nah, don't really touch home stuff yet. I might do in the future, but at the moment, nah, not really. Alright, let's try and clean this up then. Let's try and get rid of any of these little solder bridges with the stupid fine tip rubbish thing. It can't even melt a little bit of solder. Oh, man, this thing friggin' sucks. What is the point of this tip? What is its purpose? What is it useful for? Nothing. Why did I buy it? I thought it would be useful for things like this or just, you know, anything really. But no, I was wrong. It's useless. Absolutely pointless tip. Okay. Okay, that'll do for now. It's used for macro soldering, but it has such a low thermal mass. So even with even when I've been doing some micro soldering with Nintendo Switch consoles, it doesn't even work for that, because the tip, the tiny point of the tip, doesn't get hot enough. So it gets hot enough like towards the top. So what happens here? If this is heated up with the maximum temperature possible on my iron, right? It melts solder from here. It melts it fine here. Fine. But then it stops melting solder right at the top. So the solder just kind of accumulates around this middle point here. And so when you're doing stuff with the tip doesn't ever get hot enough really to melt anything. It just so shit. It's such a crappy fucking... Sand the tip down a little. You know what, actually, Anthony, that's a fucking good idea. I could give it a little wedge tip, couldn't I, with a bit of sandpaper. I think that's probably what I'll end up doing, actually. That is a fantastic idea. Yeah, I could do the clean as well. Too bad, I need my AVvvaa MX90 integrated amp fixed. I used to hear Miami bass with it and annoyed my neighbours up to a block away. Nice. Yeah, I should definitely file it down. That's actually a much better idea. I'll do that. Hello, Jesse. Yo, what's up? Man, we've got all the old school guys in here this evening. Awesome stuff. Okay, so let's drop in my new op amps then. Let's have a look. Where are they? Where's the new ones? TL074C, TL074CN. Although what might be interesting actually now is just let's fire it up one more time with these removed, and let's just check that we don't have any DC where we shouldn't have it in between these pins and stuff like that, which will prove yes or no whether the op amps were actually the problem. Actually, there's one hole that just didn't quite get sucked here. Let's just do that one. There's one that's still got just a bit too much solder in it. There we go. Nicely done. So yeah, let's just power it up one more time and just make sure that the only thing, so now the only thing that we should be seeing anywhere is clean audio. Okay? Let's switch her on. Let's have a look. 54 Hertz. Power her up. Remote cable, shove her back in because she's fallen out again. Okay. Yes, clean audio. Nice. Just checking the other pins, checking we don't have any DC. So the DC that was on the other pins of this this op amp has now disappeared, which is good. We don't have any, so we shouldn't really get on op amps that are for preamp section. If you ever see DC on any pins other than the VCC plus minus, that's a problem. So here we have minus 12 volts on VCC minus, which is great. All the DC has disappeared. Cool. So if it was a leaky capacitor or something else in the preamp section, then you know, there would still be DC there, but there isn't. So therefore, I should be able to drop in these new 074C chips, and yeah, it should work fine. Let's line these pins up, get these dropped in here, squeeze these a little bit. They always come like with the pins a little bit kind of too far out. You need to squeeze them in a little bit, get them to go in. There we go, there's one. Let's do the same to the other one. And there we those two. Hopefully all the holes got sucked good enough from the solder. Yep. Oh, they're so tight. They are touching each other there. They are like properly right up, straight up touching each other. So now, what's the best? I wonder what the best way to go about soldering these in. I've got a few options. So obviously I don't have my proper soldering tip. I don't trust this thin tip to have enough thermal mass to solder these legs in. So it's going to be hot air. So I think what the best thing to do is maybe going to be to use some solder paste. Solder paste is really cool stuff. It starts out as paste, and then when you heat it, it turns into solder. Either that, or we can just run some hot air and just feed fresh solder wire in. But I'm just worried about getting the board too hot by doing that. So I think I'm going to start off with some solder paste and see how we go using that. Just got to find where I put my solder paste. I think it's usually in this drawer here. A drawer here with a few bits and pieces in it. There we go, there's the solder paste. Well, it could be a COVID-19 vaccine. Add flux, then add solder. Yeah, so I don't think that... I'm just going to try the solder paste first. That's first. I'm going to add some flux first. Add a little bit of flux just on these legs. The solder paste I think has flux in it anyway. But, you know, you can never have too much flux. So I'm just going to bang some flux in here real quick. Then I'm going to bang some solder paste. I'm going to use a fair amount. So solder paste is typically designed for, you know, when you're doing surface mount stuff. So I'm going to probably use, you know, like a fair amount here because it's got to go down through the via and into the bottom, because there are some traces that are on the bottom of this, not just top. Okay, that's one. And then when we heat this up with the hot air station, I'm going to want to turn the pressure down, because if the pressure is as high as it is now, it's just going to blow this paste underneath the ICs, and it's not, you know, it's just going to blow it around too much. So I'm going to want to turn the pressure down. So that it just heats it without blowing it around all day long. Okay, let's try that. So air pressure going down. Let's go down to about, I think about 16, 18, and we're going to want to turn the temperature up, because this station is pretty cheap. So if you go down on the pressure, you don't get as much heat coming out of it because it cools down too quickly. So let's give this a go now and let's see what happens. Which camera's better? I think probably, I don't know, this one or this one? Maybe this one actually. It still blows it around a little bit too much. Got to go down to 12 on the pressure. That's a bit better. There we go. That's working nicely. Oops, blister. I got a tiny blister just then. That's what we were trying to avoid, damn it. Maybe I need to preheat the board a touch more. Tiny blister. Actually, better idea. I'll do something that I do with Nintendo Switches. We're going to take the tip off of my hot air station, right? By taking the tip off my hot air station, we get a much bigger surface area that the hot air comes out of. So let's take that off real quick. And then we're just going to go above the chip, and we're going to heat the chip uniformly, all legs at once. So there we go. Taking the small tip off, and we're just going to go down on the chip like this. Turn the pressure up. Turn the temperature back down. It's a bit too high at the moment. Let's go down to about just 390. Pressure up. And let's see if that does a better job. Bit more pressure, I think. That's gonna heat over a much wider area and much slower as well. It smells real hot. It smells like melting plastic. But the solder paste is not melting. Fuck's sake. I just wish I had my decent tip. It would be done in 2 seconds. Okay, that solder paste is melting now. Everything just smells really goddamn hot. Okay, I'm gonna try and do the last bit with the iron. The only other tips I've got for air are smaller ones. I don't have anything in between. So the issue I have with flattening this solder tip is that when I flatten this solder tip, I'm going to lose the coating. So this solder tip has a coating on the tip, which you know allows it to melt solder. But if I flatten the tip, then I think it's just going to not really. I think the material underneath the main tip is not good. Here, this is actually working okay now. Now that the board's got some heat into it, it's not taking away too much heat from the tip, so this actually works okay now. Lord Almighty, the 15th of December cannot come quick enough for my new soldering tip. It's so frustrating trying to work without it. Okay. Yep, cool. So that is all of the legs soldered. I'm not proud of that. That was janky as fuck. I wouldn't be happy with that. If that was anyone else doing that, I would have been like, hell no, what the hell is he doing? But it is what it is. Okay. Okay. So then, that should now have been, that should be it. That should have been what the issue was. So now let's put the filter board, actually no, let's leave that out. I just want to make sure that we have clean audio going into the filter board pins first. Want to buy a cheap iron to get you by, because the cheap irons, they don't heat up enough. They'd actually be worse than this. I did look at actually just getting a cheap one off eBay, but by the time it arrived, my tip was going to be here anyway. When I move workshops, when I move into the new place, I'll have a reserve. I'll have a backup iron, or I have a couple of different irons that I can switch between. But you know, right now, this AOUA one's done me perfectly for so many years. Never had an issue. I couldn't get the tips for it. That's the problem at the moment. So that's the only time that I've not been able to get the tips on like next day delivery. So that's why I wasn't really prepared for not having the tips available to me. So I wasn't used to that happening. So okay, cool. Let's power it up then, and let's see if we now have clean audio on the input pins to this second filter board here. Okay. Yes, we do. Awesome. So this is now probing the audio input pins to that secondary filter board, and that we had some crazy DC there before, didn't you remember? Whereas now we have a nice clean audio wave. Okay, awesome. So by that basis then, if I put this filter board back in, we should get nice clean audio on the outputs of this amplifier. Yes. Line these up, push her down. Okay, turn the gain down a touch, fire her up, and we're going to probe the audio. We're going to probe the speaker terminals now over here. Let's pray that we have good sine waves on the speaker terminals. Uh-oh. Okay, why is there no... Why do we have a sine wave? Sine wave going in there. That's funny. That's a funny. Oh, hang on a minute. There's no Class D switching. Wait, what? 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 Why is output section not switching now? It's been switching this whole time. I haven't changed anything. Oh, perhaps it's because I disconnected this screen here. Look. I disconnected this screen. Maybe that's got something to do with it. I doubt it though. All that is just a screen. Why would that cause me to have no output switching? Let's plug it back in anyway. Turn the voltage up a little bit. Let's go up to 11 volts. What? What the hell? How has that happened? That's mental, that is. Okay, well, let's remove this. See if that's got anything to do with the Class D switching being there or not. Okay, nope, still no Class D switching. So where's that gone then? Why is the Class D switching all of a sudden disappeared? Alright, so now we have a new problem. No Class D switching. Let's make sure that we have all the low voltages going into the driver board here. So we need plus minus, I think it's plus minus 15 volts or plus minus 5 volts. We need 12 volts reference negative rail. So let's have a look here. Let's go ahead and probe the back side of this driver board. Let's have a look for the voltages that we need. We have PWM, that's the oscillator output, 22 kilohertz. So we're not actually, that would go to a much higher frequency. So the oscillation generation circuit is working. This pin here, we have plus 5 volts, yep. This pin here is ground, this pin here is nothing. This pin here, we have negative 5 volts, and this pin here we have negative rail. Okay, minus 59 volts, I think that's negative rail. Let's have a look over here. Oh no, that's not. I think that's 12 volts reference negative rail. Negative rail is going to be negative rail is going to be negative 71 volts. So we have 12. We have all the voltages there that we need. So let's just check the pins over here. We have this one here, negative rail, minus 12 volts ref negative rail. That's just going to be ground, that's just going to be high side output, and that's going to be high side as well, feedback. So all of the voltages are there. So why is it just now deciding not to have any switching? Ah. Let's give it 12 volts. Let's give it 12 volts, and let's also give it a bit of gain. We're just gonna try and kickstart it into operation with the level. So turn the gain up a little bit on this filter board. Normal, off, full range, and yeah, that should be good. Bass boost off, low pass. Okay. Stick that back in. Okay, so we're up at 12.3 volts now. Remove the RCA just in case. Let's try again. Still nothing. So weird, so strange. Okay, RCA is going back in. See if we can kickstart it with a bit of signal. Nope, nope, nothing at all. Matt, how's it going, my man? Crazy, good to see you. Good to see you, man. Not seen you here in a long time. Fuck's sakes. Why would this decide all of a sudden to just quit switching? So strange. Okay. So we were soldering over here. Okay. Which is just by the op amps over here, just to do with the audio signal. So I can't really see why doing anything over there to do with the preamplifier audio signal would have anything to affect the switching going on over here. Yeah, you know, yeah, we were heating up some of the solder, and we sucked some of the solder from some of these holes that are around the TL074Cs. However, this circuit doesn't have anything to do with output switching, you know. We have all of the right voltages on the output driver card. All the correct voltages are there. All the correct voltages are present. We have plus minus 5. We have, I think we have the plus 12. Let's just double check that. Double check everything. Go back on the scope screen. Let's give you every single voltage that we have on here. So we have PWM oscillator output on that pin. This pin +5. This pin 0. This pin 0. This pin -5. This pin is 12 volts ref neg rail. I don't think we're supposed to have like a +12 reference main ground. I'm pretty sure that we're not supposed to have that. Although interestingly enough, look over here. This amplifier has had some stuff replaced before. Over here we have a KA78L. What's that say? It's got some thermal paste on it. Maybe we're missing a voltage. Maybe we're missing +12 volts. Oh, that's a 5. So that's 5. So we have +5 and we have -5. And the +5 and -5 are derived from the ±15. So I don't think that that's a problem. We have the 7812 over this side. Here, this 7812 regulator is for the 12 volts reference negative rail. So that's not a problem either. So now I'm just going to remove this one. We're just gonna see and confirm that we have the ±15. I think that should be. No, this is ±12. Here we go. We've got a KA7812 and a 7912. So let's just make sure we have +12 and -12 over here. Okay, so on the output we have -12 on that one, and on the input of that one we should have like negative, I don't know, -17. There we go. And on the output of this one we have +12. Yeah, so they're working just fine. So something is preventing us from getting output switching. What could that be? So strange. Matthew, thanks for the 10. Why do valve amps, etc., guitar amps seem to output more power than they're rated or are louder than solid state equivalent? E.g., 1 watt guitar amp can power a 70 watt 5 watt speaker with ease. Obviously a 1 watt guitar amplifier, yeah, it can power the 75 watt speaker, but remember that 75 watt speaker is very, very, very efficient. And as you get more watts, the loudness factor per watt decreases. It's like a curve. So 1 watt can actually sound, reasonably loud. It can drive the speaker just fine. I remember powering a big 12-inch 70 watt speaker from a 10 watt Yamaha amplifier, and it sounded very, very loud. But also valve amplifiers and stuff like that, they clip very softly. They don't give a harsh clip, so you can actually be outputting quite a lot more than 1 watt into some sort of clip with the tube amplifiers, and it actually sound okay. Is it in protect? No, it's not in protect. The relay's clicking. The amplifier seems to come to life. Let's just flip her over and let's just see what the screen is saying. This has a screen on the top here that tells us what's going on the amplifier. So a little screen. So if we flip her over and power her up with the screen, you can see what it says. See what it tells us about what's going on in here. Oh shit! Actually, no. What the hell? The screen isn't showing anything anymore. Oh, fuck. Well, that might have something to do with it. We just have a blue... This should usually say, like, checking and then OK. What has happened, guys? What has happened? Very interesting. I'm going to probe this 74HC because I believe that has something to do with the... I mean, this has been replaced before. Okay, and if something's been replaced before, I'm interested. I mean, I want to check it out. I want to see what's going on. This actually now doesn't have anything on it. This has nothing on it. This used to have some kind of PWM, some kind of DC. This has nothing now. So whatever's going on. Oh, here we go. We've got 5 volts going in on this pin. 4.4. Before I had some signal going in, so let's plug the signal back in. Let's reconnect the preamp board. So this time with some signal going in, let's probe that HC74HC. Let's see if that changes anything. Still not seeing any data type of stuff on here like we were before. So strange. I wonder whether heating this area of the board has killed the PIC. I don't know. There's no data going into the PIC anymore either, just DC voltages. I'm going to try and reseat the PIC into this header because headers, you know, with heating and cooling of the board over this side. Bevids, is this the most expensive amp you've worked on? Oh no, no, not by a long shot. I've worked on some way more expensive amplifiers. I'm just going to try reseating this because, you know, we have heated and cooled the board over here, so. I'm also just going to take my multimeter and just check for any shorted capacitors or anything around here that were maybe on their way out. Let's power up again. Nope, still nothing. I can't see why that would have an effect on the output driver card. I am pretty lost, not gonna lie. I am pretty lost about this one. Very, very strange. So there's our sine wave coming into this op amp over here. Now let's check this top op amp. This was the one that was kind of having some DC on it before. Actually, hang on a minute. Hang on a minute. There's DC back. Hang on a minute. It's gone back to doing the same thing it was doing before. Something is killing those op amps. It's doing the same thing it was doing before. Something is killing those op amps. Look. We got that janky DC with the sine wave again on it. But this time we also don't have any output switching now. What the hell? Right. Time to remove these one by one. Yeah, there's definitely not enough space here on the board to install the dip sockets, I don't think. Otherwise I would. And also I don't actually have any dip sockets. That would be nice actually, yeah. Having some dip sockets would be really handy about now. I wonder if there's any dip sockets on a spare board that I've got. I don't think there is. Rebase Music said... I don't know, what did he say? What did he say? There's no question. I want to see my name pop up in the video. Well, there you go, my friend. I even said it out loud. Oh, Bevids, hey, this is off topic, but if you see this, please answer. As long as the remote terminal is seeing 12 volt, is it true you can send 18 volts to an amp without it protecting? No, that's not true at all. The amplifier doesn't really care what voltage is on the remote terminal. It's looking at the voltage on the power supply terminals, not the remote. What's your opinion on Preamps? I have a Smart 3K and I love it. Yes, I don't like the older HD series, they sucked. However, the Preamp Smart 3 is an absolutely brilliant little amplifier, and I recommend it to many people looking for around about that kind of power at 1 ohm and 2 ohms. You can't go wrong with the Preamp Smart 3, it's an absolutely awesome little amplifier. Okay, cool. So now that we've removed the 2 op amps again, it's possible that one of them died. So I just want to, out of interest, try powering the amplifier up now and seeing if we have our output switching come back. Because I'm very confused at why that decided to disappear. So yeah, let's turn the power supply on. Let's see whether the amplifier wants to come on and switch now. Fuck's sake, no, still no output switching, and I bet you that the screen is still not doing anything. Nope, still nothing on the screen either. Fuck's sake. So weird. I wonder what happens if we, I wonder if somehow the PIC has died for the same reason that the op amps have died. I wonder if removing the PIC will, I don't know, like prevent some kind of protection signal from going into the amp and allow the output section to start switching. Let's see. Where the hell are my pliers? I had them like 2 seconds ago, didn't I? Where the fuck are my pliers? Right, they're here. Okay. Let's remove that. That's to run the screen. So now do we have output switching? No. Okay. Still don't have output switching with the PRC removed. So it's not to do with that. So, Amplifier, why are you killing my op amps? Why are you killing my op amps? Let's see if we can figure out which one of these op amps it's killing. Let's just move the amplifier for a minute. Let's just move it here, and let's put the op amps just into this foam pad down here. Just to kind of keep them in place for a second. Let's see if we can use our multimeter to try and figure out which one's died. Actually, that doesn't help me because I mixed them up now, so I don't actually know which one. But I want to see if it's killing both of them or just one of them, maybe. So what we're looking for is we're looking for leaking between the VCC and any of the other pins, because we've got DC on the other pins. So if I give the positive terminal to that, so we should have like 612, 605. Yeah, that's about right. 600, 600, and then go over a grand. 600, 600. Over a grand, okay. Other side, 600. And I'm also going to grab a new fresh one and just compare the readings and see whether they're the same or not as what I'm reading here. Okay, now let's try the other VCC input. So there's no shorts. Okay, let's grab a new 074C and let's compare readings and let's see whether they're the same or not. There we go, there's a new one. So we have the same readings. Maybe, you know what, maybe it's not actually killing the 074Cs. Maybe just by applying some heat to the board, it actually kind of changed the characteristics of some slightly faulty component. And then when the amplifier's cooled down again, then the issue has come back. So maybe the till 074Cs actually aren't dying every time. because I'm not really seeing any huge variance there that would, you know, indicate leaking. But what I want to try and work out before I put the new 074Cs in, I should still have output switching at this point. I am very confused why the output section has decided to stop oscillating. What I might have to do, guys, is I might have to go and grab the other one of these amplifiers and just take some comparative readings between these, because we're not getting a protection signal come in, I don't think, to the driver board here. So the output driver board, I don't think we're getting a protection circuit coming. So the chips should be coming to life. Now these are IRS21844S. So let's take a look at the data sheet for those real quick, and let's take a look at the shutdown pin. Because if the shutdown pin, I think, is high, then the amplifier won't come on. So, can't remember which way around it is. Here we go. Shutdown is pin 2. Ah. Okay, shutdown is pin 2. So, let's grab our probe, and we have to be very careful in here. So tight in here. So shutdown is pin 2. I'm going to try and power the amplifier up and try and probe pin 2 and see what is on pin 2 of this amplifier here. Just to try and see whether it's high or low and see what that tells us. Because it must be that the chips are in shutdown, and that's why that the amplifier is not switching. It must be that that's the case. Let's power it back up. Just confirm that we're still not switching. Okay, yes, confirm that we're still not switching. Okay, so now if I very, very carefully get my probe in there, try not to short out anything, and let's have a look at what we have on the scope. Okay, we have negative 64 volts, which is, the rail voltage here is, negative rail is negative 67. So we have like about 5 volts by the looks of it on shutdown pin 2. Although not even 5 volts. It's like, it's really close to negative rail. Let me get another probe here. Let's just grab a second probe. Let's zoom right in. And let's put the second probe on negative rail, which is the ground reference for the shutdown pin. Now let's probe the shutdown pin with our ground pin hooked up with our negative rail. Okay, no, it's actually at 0. It's actually at negative rail. So yep, okay, so no, there's 0 volts on the shutdown pin. There's not actually any voltage on the shutdown pin, it's at 0 volts. Now I can't remember for the life of me whether shutdown should be high or low for operation on this amplifier. Can anybody in the live chat remind me? Remember, on an IRS21844S, should shutdown be high or low for operation? Here we go. Yeah, thank you very much. Tacit. Shutdown SD is active low, so it is off. Okay, so shutdown then, that pin is the reason that we have no switching. So we need to figure out what connects to the shutdown pin on the driver card and trace that back through the circuit and find out what's not happy. Shutdown SD active low, so it's off. Does that mean that shutdown is causing this? It was on your data sheet. SD, was it? Where did I see it? Where did I see it? Switching. Oh, shutdown waveform definitions. Here we go. Sorry. Okay, my bad. Shutdown. It doesn't. Yeah. That doesn't actually tell me though whether it should be high or low, right? Or does it? SD. Logic input for shutdown, reference to COM. Oh, it's reference to COM for iOS 284 and reference to VSS. So VSS pin number 3. So let's just check VSS is the same. Yeah, VSS is also negative rail. Okay, that's fine. There is a bar above the SD name. Oh, I see. The bar above the SD name. So that means, what does that mean then? Does that mean that when it's high, it's active? So just clarify for me. So my brain is frying a little bit at the moment. So when shutdown pin is low, does that mean that the chip should be active? Or does that mean that shutdown is active? Means active low. Okay. So that must mean then that with shutdown at 0 volts, reference negative rail, so with shutdown pin at negative rail, that means that the chip is in shutdown, correct? Check if on pin 1 we have switching waveform. Oh yeah, that's the next thing we can do as well. That's one thing I usually do and check. So on pin 1 we have the input pin, so we should have PWM about 22 kilohertz on pin 1. Let's have a quick look, see what we have. Yep, we have PWM on pin 1, so we should have output. What the freaking hell is going on? So the chips must be in shutdown. That's the only explanation. We have PWM inputs pin 1. We have all the correct voltages, +5, -5, +12 ref negative rail. We have all the right voltages. We just don't have, the chips aren't working. So yeah, it must be bar above means active low. So I think that the chip is in shutdown. Why is the chip now in shutdown? It must be something to do with the PIC. It must be over here. It must be something to do with this not actually working or something. Maybe this 74HC95595, maybe this has died. You know what I'm going to do? I'm going to remove this. I don't trust this. I do not trust this this chip here. It's been soldered in before, and I don't think I trust it. I'm going to remove it and see if that causes the amplifier to come back to life, just out of pure interest here. Snipex says 12 SD should have 12 volts so that the amplifier turns on. Okay, so there we go. The chip is in shutdown mode. The 595 is a shift register probably used by the PIC to multiplex the display. Well, this might have something to do with why we have no screen display at the moment. And I'm wondering whether if this is bad, it's kind of sending some strange DC to other places, which is causing the output to be in shutdown mode. Okay, so that's that removed. So now that we've removed that, let's power the amp up again and just see if we now have output switching. Yeah, look at that! What a guess! Alright then. So, something is wrong with the whatever the fuck this is, MC74HC959. I don't even know if that chip is legit. That looks like it could be a fake. Like the top looks a bit like it's been sanded. So okay, Okay, so something then is wrong with that, and that was causing the amp to go into shutdown, probably backfeeding some kind of nonsense. So the screen probably still isn't going to work. Let's have a look at the screen real quick. Because now that we've removed that shift register, it's probably not, the screen's not going to do anything, probably, is it? To be honest. I just want to see. Yeah, no, the screen is dead. So the screen lights up, nothing displays on the screen. All right, great stuff. So my little guess there with the shift register was correct. Now I wonder whether the shift register being bad was what was killing my my 074Cs as well. It's possible. Although, strangely, we did originally start this live stream with output switching on the outputs, so strange. What I might do now, then, is I might put some 074Cs back in the board. I'll put some new ones back in, even though the ones I took out didn't appear to be dead. I'll put some new ones in, because these are only really cheap. These are really cheap anyway, so I don't care if I kill too many of these. Put some more of these in, and with the shift register removed, the amplifier comes on, so I should get clean outputs, right? So once we have clean output, we see how long the amplifier lasts. We see how long that clean output lasts. What did I just do with the? Hang on a minute. Nope, that's this shift register. Where's that brand new 074C I just had? God damn it. Oh, here it is. Okay, sweet. So 2 brand new 074Cs. The heat could have killed it, possibly. Yeah, possibly. Although there wasn't a bunch of heat around the area, but you know, yeah, absolutely right. It is possible the heat may have killed that. But it wasn't proper cooking that up, you know. It wasn't properly cooking that up like crazy. Okay, so let's get the new op amps, and what I'm going to do is I'm going to solder these in. I'm going to do it without sucking the holes. I'm going to just try and drop it straight in by melting the solder here. Now this is going to be perhaps a little tricky, a little risky, but I don't want to sit here and suck the solder from all these holes again, because it was bloody time consuming. There we go. I should be able to get that in with those pins lined up as they are. Yeah, that looks pretty good. I should be able to get those in. All right, let's give that a go then, shall we? It's going to drop a little bit more flux. Drop a little bit more flux on here, and yeah, we're going to preheat the area. I'm not going to use my big hot air gun for this. It's going to use the smaller one because I don't want to get any heat into other areas of the board unnecessarily. So it's going to draw some circles here with the small tip hot air gun, just to kind of heat this general area here. Is this another stream where live chat fixes the amp? River Alley. Haha. Cheeky. So if I wasn't live streaming right now, for the information about the shutdown pin, Perry's guide actually has that information, which is pretty cool. But it was easier to ask you guys and see if anyone on here is a little bit more rememberable than me with that specific little detail there. She's going in. She's going in. Okay. I just need that to set just to get rid of my tweezers, because my tweezers are now stuck. There we go. So now if I just heat around it, it should fall in by itself. Might just need to give it a little bit of convincing. There we go. There we go. She is in. That's how you do it. Right, next one. That's an old one. That's a new one. Let's line those pins up. Pull the PIC to prevent any damage to that. Okay, yeah, we'll do that. Although I imagine, to be honest, I'm not really heating it like I was before. But yeah, it's not a bad idea. Let's pull the PIC. What hot air station do you use? I use this really cheap, crappy AOUA 2738A+. It sucks. Don't buy it. One thing I did to the... Oh, that's not... The shit register has shut itself. Yes, Michael, it has. The shit register has shut itself. There we go, one side in, now just a little convincing. On the other side, and here we go. Oh, just come out. Come on. You can do it. There we go, she is in. Cool down now. Okay, cool. Would you ever get into repairing home amps in the future? Sometime in the future, yes, maybe. Not now, though. Not yet. Right, so let's put the preamp board back in as well. So now what we want to see is for the first time this live stream, clean audio on the outputs. This doesn't look so legit, you know. I don't know. Is it going to focus? This kind of gives me the vibes of like a Chinese eBay kind of job, but you know, I don't know. It does have the indent over this side, but there's something about the text that just doesn't look quite right. Don't know what it is. Okay, so the PIC is out. PSE is out and the shift register is out. All we have now is we just have the amplifier stage parts in. So now we should, fingers crossed, get audio on the outputs. Let's find out. Oh no. No audio. We have switching. We have nice wave. Why no audio? Do we have a sine wave on the op amps? Yes, we do. Do we have a sine wave going in? Yes, we do. Now this is just one thing after another, isn't it? But no audio on the outputs. Okay. Yeah, the amplifier does come on. Let's put the PIC back in. Let's just in case that was something to do with it. The PIC, the PIC is just for the screen. It's just a program for the screen. It's not for the amplifier. But let's just see. Okay, so no, still no audio. Subsonic filter, let's turn that off. Normal inverted, mode full, level, it's down low. So shutdown is not going to still be low, because if shutdown was shutting the chip down, we wouldn't get switching. So the issue that we've now got is that it doesn't seem that signal is making its way to the driver board. Or something like that. What the fuck, man? Yeah, we have audio signal with the preamp board here. This filter board. Now, do we have that going into the driver board here? No, we don't. Man, this is mental. I'm just checking the pins of this shift register, just in case we have any like stuff on it that might be to do with audio, but I don't think so. Nope, 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 there's nothing to do with audio there. One last thing I want to try in terms of audio. Actually, hang on a minute. We don't have any audio on this second op amp. This second op amp, this used to have audio on it. I'm pretty sure. Although actually, maybe that's for different. Maybe that's for channel L. Maybe. I'm pretty sure this. Oh no, it does have audio on it. There we go. So let's probe some of the potentiometers here. So on the back of this preamp board, we've got some potentiometers for like gain and stuff like that. So these should have the audio signal on them somewhere if it's making its way to them. Here we go. Got audio signal on this one here. Audio signal in, audio signal out. Yep, so there's audio signal on this potentiometer here. That's a good sign. Let's check the one over here. Yep, there's audio signal on the one over here. There's audio signal on this pin over here. Okay, so the next thing to do then, I don't think that signal is making its way from this final filter board here to the driver board. So what I want to do is I want to take a note of which pins of this filter board have the audio on them with this filter board removed. So I'm going to remove this filter board. I'm going to take a note of which pins have that audio on them with the board out. And then I want to look for, what we're looking for then is we're looking for extra pins once the board is in, which will be the output pins. Then we can trace it to the driver board. So let's power the amplifier up and let's see which of these pins have the audio on them with the board removed. So I'm going to sort of start labeling these. We're going to probably make a mental note of these, of which ones have the audio on them. So pins, so these are just doubled up. So although these look like double, they're not. So pins 1 doesn't, 2 doesn't, 3 doesn't, 4 doesn't, 5 doesn't, yep. Okay, 6 doesn't, 7 doesn't, 8 doesn't, and 9 doesn't. So already I remember that there was audio on pin 4 with the filter board in. So I imagine that that's probably the output. So the input is going to be over here. So over on this side we have audio wave on pin 3, pin 4, and that's probably it. Yeah, okay, excellent stuff. So with the board out, we have audio on pin 3 and 4 over this side, and nothing over this side. And with the filter board in, drop that filter board back in like so. With the filter board in, we have audio on, so nothing 1, nothing 2, should have audio 3, should have audio 4, 5, 6, 7, 8, 9. Okay, so and over on this side we have nothing 1, 2, 3, 4, 5. Okay, so there's audio output on pin 5, 6, 7, 8, 9. So pin 5 then must be the final output from this filter board. So let's remove it again. Oh, thank you very much, 515 Earl. Massively appreciate the 5, buddy. Really enjoy your content. Thanks for taking the time to do what you do. Hope your car gets sorted. Thank you, dude. Car's getting sorted as we speak. I really appreciate the 5, man. That's awesome. Thank you very, very much. Hey Sam, way OT, but has the guy from Tech Stuff Tuesday ever responded to your video? No. He won't ever respond to that. Do you have a Patreon? Yes. I can't remember the details of it though. I made it years ago and I haven't looked at it for a long time. General question off topic. Well, what could be the reason that the power supply MOSFETs are getting hot under no load? Only one channel does this. You want to be checking the drive wave shape on your oscilloscope. If the bank is getting hot, then often it means that the drive to that bank is poor, so you might need to change the drive transistors. It could also mean that you might have a slightly shorting transformer on that bank. So if the drive looks the same shape as the cold side, then it's most likely something on the transformer or rectifier section of that bank that's getting bad. What's up, Matt? Oh yeah. Okay, so now that we've discovered that it's pin 5 that has the... Wait, what? Hang on a minute, the amplifier is off. But I have that on pin 5. It goes away when I turn the amplifier on, okay. That's strange. With the amplifier turned off. Look what I have on pin 5 with the amplifier turned off. That's funny. I'm sure that's just a strange effect of having the gain turned up too high. I'm sure that's nothing to worry about. So yes, pin 5 then is the output of the filter circuit, because that one has the audio wave on it when it's fitted. So we need to follow where pin 5 goes. Now the trace is obviously on the underside of the board here. So I want to just try and figure out. Unfortunately, actually, the fact that that's doing that means that I can probably just very easily see which pin it is. So it's not that one. I want to see what has continuity. So I'm going to shove my probe in there. Going to use my multimeter now to check for continuity around the board. We're going to find where that leads to. Nope, that's just negative. Okay, looks like we have continuity to this resistor here, which is R34S, which I believe might be signal. We also have continuity to this capacitor. Okay. There's also another one over here. Maybe it sort of loops round. So we should have audio signal there, and then we might have audio signal on the other side there. I just want to check that that's not ground. Just want to check that's not like a... we have 47 ohms to ground over this side. That's interesting. I wonder whether there should be 47 ohms to ground. That would mean that we might be grounding our signal. Okay. Interesting. Let's just continue looking and see if we find any other continuity to this signal output here. If I could be bothered to take the PCB out, then obviously I could follow the trace, but unfortunately I can't be bothered to do that. It's a really big effort with this amplifier to take the PCB out of the case. There's so much involved in taking it out. Okay, so what's on this side then? So if the signal does go through R34S, then on this side we have continuity to over here. Now this is a pretty big trace. I doubt that this trace is meant to have signal on it. This is like a really thick trace. This is more like a kind of ground trace, if you ask me. And this large trace here has 45 ohms to ground. Okay. So with that in mind, let's put this filter board back in and let's see where that signal goes. So pin 5, 1, 2, 3, 4, 5. Ah, bugger. So with the board in, I can't actually get to that resistor. Ah, that's so frustrating. Perhaps I could bypass this whole section by connecting one of these signals over here to pin 5 over here. Because they're about the same amplitude. We've got 2.6 over there. And on the input over here, we've got about 2.7. And 1.9 there. So I might actually be able to bypass this filter board by jumping over, by taking the 2.7 on pin 3 over this side and just jumping it over to pin 5 over on the other side. Let's do that. Let's grab a spare piece of wire to jump over. Let's grab some of these. You said you'd have the board out ready for the stream. Yeah, but then I remembered that I probably don't need to take the board out. Like, to be honest, this repair is really weird. So I looked at the board and I said, no, you know what, I can surface mount desolder everything in here from the top. And I was very busy today as well, so I didn't actually get around to taking it out. We could take it out quickly now. I could try and do it real fast. But yeah, we know that we have continuity to there. Taking the board out probably would help a little bit though. If this doesn't work, if jumping this over doesn't work, I'll take the board out. Everyone's saying just take the board out. Okay, fine. Missions. I just want to try this first though. One, two, three, four. 1, 2, 3, 4, 5. Okay, let's see what that does. So we should get signal on this pin now. Okay, yep, we do. So we get signal on that side, nothing on the other side of the resistor, obviously, because this seems to have 47 ohms to ground, which is very strange. I don't know whether that should be there. This is getting pretty in-depth now. And I'm going to need to trace the continuity of this pin 5 and find out where it goes before it goes into the driver board here. I wonder whether this op amp, this is a this is an LM29, I can't see that, 293N. I wonder if this has got anything to do with it. This just has negative rail on it. Yeah, so guys, I think the answer to this one, I think the solution to this one is to take the board out, get the other one of these, because I've got 2 of these, which is a godsend, because it means that you can use both of them to repair each other. Get the other one of these, and I think the other one has like a blown power supply section or something like that. So the output section should be okay on it. So we're going to grab the other one. I'm going to use the other one to work out where the audio should go into the driver board and figure out whether there should be 47 ohms on that resistor to ground or not. And that should then tell us a bit more. Also, the other amplifier will also have, hopefully, a working 74 HC595 on it that we can steal and see if that then brings the screen to life on this one. So, yeah. Isn't that resistor part of a high pass filter? So the res would be to ground. I don't know, to be honest. I don't have a schematic for this amplifier, so I'm just kind of figuring things out as we go. Maybe I can figure out where else this connects to find out where else the signal goes. Yeah, I need to see the underside. Need to see the underside to follow the trace of this signal. Because I figured out that we've got continuity to this resistor here. And then the other side of this resistor has 47 ohms to ground. So if that is the signal path, then obviously the signal after this resistor is just getting grounded. Actually, you know what? Talking about it now. Yeah, actually, we've got 43 ohms to ground on the input of the input ring of the RCA, but we've got 0 ohms to ground on the pre-out ring of the RCA. And if we check to main ground, what do we have to main ground? We have 45 ohms to main ground, and we have exactly a dead short circuit to to output ground. So yeah, the signal mustn't be passing through that. The signal must go somewhere else. Because obviously, this is obviously a ground trace. That's fine. That makes sense. This is a big thick trace. That's obviously ground. So that makes sense. But we need to find out where else does the signal go. And I can't really trace it from the top of the board because I can't really see where it goes. The trace goes underneath the bottom of the board. And it's just going to take me forever to kind of run my multimeter across every single pad on here to see where the signal goes. Oh wait, oh no, I thought we had something then, but that's not, that's just capacitor charging or something. I'm checking all of the vias because the trace must come up to the top of the board at some time. So I'm checking all of these vias. Nope, not finding anywhere. So yeah, we have to take it apart. So what I'm thinking is that it is we're 2 hours 25 into the stream, so I can either take it apart now, or we can lock off the stream for this evening and continue with this tomorrow. And I will definitely have it taken apart for tomorrow because obviously it's quite clear that we need to do that now. We don't have any rail voltage in the amp now, which is good, so I could start taking it apart. I think that resistor prevents ground loop noise. Yeah, you're probably right. That's probably something to do with that. Hey, Mr. Beveridge, I have a really good one for you. I have a Belva 5K, and it works great. I'll tell you, it starts to warm up, then it starts to sound off. Doesn't pop or anything or shut down like that. That Belva amplifier is one of the worst built amplifiers I've ever seen in my life. I actually repaired a couple of those a while back. The build quality was absolutely horrendous. So bad on the Belva. So yeah, it could be so many things, but I imagine it could be possibly related to vibration damage. Because yeah, that Belva was just put together so badly. The board was so flexible. It was literally visibly wobbling around as you handled the amp. It was terrible. Keep going, I want to see where this goes on the other side. Okay, cool, we'll keep at it for a bit more then. But probably once it gets to about 2 AM here in the UK, it's 1:12 now. Woo, where did that go? Did you hear that? Bing! Need to go and find my... There it is. Yeah, guys, go make a cup of tea or something while I'm doing this. It's pretty boring watching me do this. See if I can read some live chat while we're at it. Do a little Q&A to finish the stream today. Whack it apart tomorrow and continue working on it tomorrow night. Okay, well, I'll do a bit of Q&A while I'm taking this apart. That sort of kills two birds with one stone. The weird thing with this amplifier though is we started out with just poor audio on the outputs, so that was obviously coming from those 074Cs. So we started out with poor audio, then we got no switching, and now we've got switching, good audio up to the preamp section, but no output, no audio on the output. It's so strange. It's like it's creating new problems all the time. Still going, huh? I had to leave to cook dinner for the wife and kids. Yeah, this amp's just creating its own new problems as we go. We fix one thing and then it stops doing something else. Really strange. Mike Honda. Nah, dude, just crack on, man. Obviously, this video is going to be here regardless. You can always catch up and watch it back tomorrow night or something, or tomorrow or another day. Don't worry about sticking around just now. We'll get to the bottom of it. Okay, I need my Allen key again. I'm going to have to go in and unscrew these bad boys in here. Couple of bolts in the board in here. Okay, then we have to remove these risers for the preamp board so that the board can slide out. Got to remove the screen. Bevis, you still doing the video where you explain if you could design your own amplifier circuit and what you could do differently to mass produce circuits? Yeah, at some point in the future. I don't feel like I am quite knowledgeable enough about amplifier circuit design to do something like that yet. But it's something that I plan to do in the future, you know, quite a way into the future probably, a few years down the line, once I get the knowledge. So now, usually on these amplifiers, I would just remove one of the end plates and slide it out from the other. But because we've got this screen wire, I've got to remove both of the end plates, slide it one way first to unhook this, and then carefully slide it the other way while trying not to pull all the wires out from the screen on the other side. It's very, very fiddly. So I need to get a bigger Allen key now for the side panels. Sorry, I just saw the stream. Can you give me a quick rundown? Yeah, for sure, buddy. Little recap then of what we're doing so far. So this Hertz amplifier came into the workshop, powering up just fine. Had output switching on the output section. Everything seemed great, but we had the audio output was non-existent until we got to clip it, until we turned it up really high. Then we got a really janky looking wave on the outputs. Really horrible looking wave. All kind of spiky and all over the place. So we took it apart, we took the top off, and we figured out that the reason for poor audio was a couple of dead TL074C op amps in the preamplifier circuit. So we replaced those. Then after replacing those, we all of a sudden didn't have any output switching. So that was strange. And then we figured out that the reason there was no output switching was because a shift leveler had died, which is part of the little screen. There's a little screen on these amplifiers that tells you voltage and amp temperature. And for some reason, with that dead, it was preventing the output section from switching. It was sending the IRS 41844S chips into shutdown mode. So we removed that, and the amplifier came back to life. So we now have output switching. We now have good audio in the preamp section, but now we have the audio is not making its way through the preamp section into the driver board, which it sort of looked like it was before. So Yes, we have, like, this amplifier is developing new issues as it goes. Yeah, the Preamp's Smart series amps are bloody fantastic. Very good amplifiers. The interesting thing is, right, guys, is that we do have audio output from the sister board. So on this board, we do have audio output. So the issue is after the sister board and before the driver board. Now I've got to take off this side. I thought this was going to be a quick, simple fix too. I initially thought that it was possibly bad, like bad switches on the preamp board, so I cleaned those up. But that didn't help. How did you become a DD dealer? I just got speaking to the right people. I got speaking to the UK distributor at the time, and we got chatting about stuff. He was interested in my YouTube channel, so he thought that, you know, it'd be good to promote DD in the UK through my channel. So that's why I made loads of those up close and personal videos with the DD woofers at the time and stuff like that. Yeah, the fans that Preamps use definitely are pretty annoying. They're really cheap, nasty fans, and so after not too long of operation, after a couple of weeks of operation, the fans get really loud, and the bearings are all kind of crappy. So if you can replace the fans, then yeah, great. They're pretty awesome. Do you find yourself explaining what you're doing out loud when you're doing repairs but not streaming? Yeah, if I get an issue like this that's a bit of a head scratcher, I'm sort of saying to myself, no, we had audio there. This is going to there. Like, it helps a little bit, you know, sometimes. But I don't, obviously I don't talk in the same way that I do when I'm streaming, but I do talk to myself a little bit. Oop. Okay, so that is both of the end plates off. So I believe now that maybe this might slide. Let's see, have we missed anything? Have we got any screws that are still in the board anywhere? Let's try and give it a little. Ah, there we go. Okay, so it's starting to slide. So what we've got to do, we've got to just slide it this way slightly, which just releases this. We bend that down under the board, and then we have to slide it out the other way, like that, and try not to. Yeah, there you go. Try, so you can see there. This looks like it's been taken out before, and this wire gets really trapped and pulled and stuff. And this is why I don't really like taking these out of their cases too often if I can avoid it. Just a bit of a pain in the butt. Okay, there we go. She is out. She's out. Okay. So now that she's out, we can properly trace where the audio signal goes after the driver board. So it's pin number 5 on this side. So let's have a look then, gentlemen. Pin number 5 on this side, where does she go? 1, 2, 3, 4, 5. Okay, it goes to 2 places. It looks like it goes up here to this resistor, which, like someone correctly said, is going to be preventing noise and stuff. But it also goes way back this way towards the preamp board, which is not quite what I was expecting. Okay, so it goes all the way along here. takes a cheeky curve, and it goes through a via over here. Okay, cool. So now we know that it's going over this way. Let's flip the board over and follow the via on the other side. There's a TL0772C there. Okay. I wonder if it goes into that. I wonder if that's a problem. I wonder if that's possibly an issue. Maybe that got killed by the same reason that the 7.4s did. So, let's see. Which via was that? There's so many via. Here we go. Here it is. And now we have a tiny little via. That's so annoying. That tiny trace on the top there. So right next to it, it goes back under the board. So we're going to have to jump back under the board now. So it looks like it just jumps over here. Yeah, okay. So let's just confirm. 1, 2, 3, 4, 5. Jumps over there and it goes into this, what looks like a resistor here. Okay. So let's figure out then what resistor is that. It might not be a resistor, it could be something else. Okay, it goes into this resistor here, which is, it looks like I can't remember what the orange multiplier is. Red is 10. No, sorry, black is 10. Red is shit, I can't even remember. Got brown, black, orange, gold. I think that might be a possibly a 10k or 100k. It's a 10k. Yeah, I was right first time. So we've got a 10k resistor there. Then after the 10k resistor, it then goes into this TL072C. Okay. So if it goes into this TL072C, then it should also come out of it. So we want to see where it goes in and where it comes out. We want to see what's on that 072C. All right. So let's power it up again and let's just see what's going on with that 072C then, shall we? Okay, RCA lead goes in. I'm going to put the filter board back in properly this time rather than just having that jumper wire. Filter board in. Another reason why it's annoying out of the case is because so the case helps this filter board stay in place. So when it's not in the case, I have to put something under the board to prevent this filter board being pushed up out of the... because obviously now it's going to rest down. It rests down onto the filter board, which then pushes it up. So I've got to grab like some pliers or something and just go under the board here to support it slightly. Still wants to push it out. Something a bit bigger, maybe a screwdriver. There we go, like that. So that stays in. Okay. Let's go for some power. Double check that we still have switching on the outputs. The remote wire's falling out again. Let's plug that back in. There we go. Output switching. Make sure that we don't still have audio. It hasn't magically come back to life. Nope, still don't have audio. Check that we have audio on pin 5 output of this, which we do, I believe. Go back on the scope a little bit down to 5-volt divide. Yep, so we have audio there. Good stuff. So now we're going into this 072C. So pin 1 has audio output. Pin 2 has 0. Pin 3 has 0. 4 has the VCC. Pin 5 has 0. Pin 6 has 0. Pin 7 has 0. Pin 8 has VCC. Okay. So pin 1 of the TL072C, I believe that's isn't that an output? Isn't that an output? Let's remind myself. TL072C. Or is that an input? Maybe it's that 072C then that's just like gone open. It's just dead now. Okay, that doesn't seem to open. There we go, 072XX. Da, 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 da. Pin configurations, here we go. So pin 1 is so then this is this relevant to figure 1? Now that's a 7.1, so we want to scroll down until we get to, here we go, figure 5.2 TL072. There we go, that's relevant to this one. So pin 1 is output 1. Okay, so we have the sine. So why would we have the sine wave? Hang on a minute. What? Why would it be going to have continuity to that? To the output. 1, 2, 3, 4, 5. Yep, so, okay, I was just confirming. We have continuity, obviously, so this resistor here. Then after this resistor, so we should have the sine wave after that resistor, even if it's really, really tiny. So let's just have a look. There's no sine wave on the other side of that resistor. Uh-oh, hang on a minute. Why is that now riding along some DC? Oh. We now have the sine wave riding along DC. That wasn't there before, was it, gentlemen? Why is the sine wave now riding on a volt of DC? Oh man, this is a freaking ball ache. Have the TL74Cs died again or leaking again now? We have, yep, we have the sine wave on DC, and we have DC over at these TLs. Oh, fucking hell, man. Yep, that's getting red hot. This TL7074C is getting red hot over here. Oh, fuck's sake. Why is it killing these? Is the VCC voltage too high? I don't think it is. What is killing these? We've got 14 volts. And we've got minus 8 volts. Something's pulling that down. 14 volts. Minus 8 volts. Thermal imaging camera. Yeah, so these 074Cs, well, one of them is getting to 60 degrees now. So yep, definitely dead. Definitely dead. Is it the top one or the bottom one? Because I don't have to replace both of them. I think it's just this top one. This top one's getting really hot, but the bottom one is okay. So if I just remove the top one. Oh, what the fuck, man? What the fuck? It's so confusing. Nice. Sean Blenheim, I see what you do. I see what you did there. I see what you did there, Sean. What does the bottom of the board look like? Yeah, that's a good point. Let's have a look at the bottom of the board around this area that's obviously been worked on before multiple times. Okay, what do we have on the bottom of the board here? If I'm honest, looks pretty clean. Doesn't look too bad. I've got a lot of old flux around the around this 74HC location. We've got a jumped. There's a jumped wire here actually for this trace. Holy shit! Generally, you know, it looks okay around here. Doesn't look too shabby. Is it raining outside? Yeah, probably. Probably is raining. I really want to know what's killing my my 074Cs. That's like, I've never seen them die so consistently before. So the only things that would kill them would be like a spike of something on one of the input pins, or like too high a voltage on the VCC pins, maybe. Let's turn the amplifier on and off a few times and let's see what comes on to the VCC pins of these 074Cs. Let's see if we get a spike or anything. So yeah, we're just going to turn these on. Let's grab my other probe right here as well. We're going to go double probe. And get rid of this filter board because that's not important right now. Okay. So let's turn her on with it like this. Let's see if we can see any strangeness going on with the VCC going in here. No, that looks good. That looks like it builds pretty normally, doesn't it? Builds and falls pretty normally for the VCC. Okay. Is there any spikes on any of the other pins as the amplifier turns on? I'm checking pin 1 right now. Not really. Pin number 2. No. Pin number 3, 4, 5, 6, 7. Not really any spikes or any reason that I can see that would be dying. So audio input is pin number 3 to this top one. Pin number 3 just there, you can see on the scope screen. We won't have any audio anywhere else yet, obviously. Huh. Check resistance between the outputs of the op amps and ground. Yeah, okay. Let's give that a go. See if that tells us anything. Nothing yet. Pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pin number 10 has 47 ohms to output ground, and it has 47 ohms to output ground there. So does pin number 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. So pin 10 and 12 have 47 ohms to output ground. Let's have a look. Don't seem to have the pin out of this. Where's the pin out of the big ones? Oh wait, here we go. 10 is 3 in plus, 12 is 4 in plus. So perhaps they're not used, or that would make, that's fine. Having ground on 3 and 4 in plus is not an issue. That wouldn't be causing us to kill these. Okay. Let's grab another one, even though it's probably going to kill it. But what I want to do now is I'm going to drop another one in, and I'm going to monitor the temperature on it at all times. We're going to idle the amplifier for a bit, and we're going to monitor the temperature on it. See if it's like overheating perhaps. There we go, there's one. I am running out of these now though. Is this going to be one you won't be able to repair? I will be able to repair this, but whether it's worth the amount of time that's going to be required to find all the issues and repair it, I don't know. She's in. It's really strange because so like these TL7074Cs are dying. We had this level shifter die. This 74HC thingy. It's just a really weird one. Okay, let's wait for that to cool down, and then once that's cooled down, we'll get the thermal imaging camera out, and we'll monitor the temperature on it while it's operating. If all inputs are correct, then something on the output must be drawing too much current. So the output pins for this are the active output pins that we're actually making use of. We've got pin 1, pin 1 and pin 7, pin 3 and pin 4. So yeah, the corners of this op amp are the outputs. So I didn't notice any considerable like low resistance from the outputs to ground or anything. Got nice high resistances. Although, actually, hang on. I'm going to take it off diode mode, and I'm just going to leave it on regular resistance mode here, just to read pure resistance. So I want to double check that we don't have any like actual low resistance to ground on any of these. No, so we've got over 2 kilo ohms at least. 16, 17, 18. Yeah, we've got really high resistance on these outputs. 8, 9, 10 kilo ohms perhaps on this one. 10, still going higher, charging capacitor. 6 kilo ohms on that way, one way round. 18, yeah. So yeah, none of the outputs have any resistance to ground at all. Okay, so what I'll do now is, now that we've replaced that 074, let's put the filter board back in. And this time I'm not going to leave the amplifier powered up for too long. I'm just going to like pulse it on and off. Hopefully that will mean that we don't kill our TL074Cs so easily. Whatever's killing them, hopefully they last a little bit longer than they have been. I just want to try and follow the sine wave through here. Now, really weirdly, we had the sine wave going into this resistor here, this is a brown, black, orange, gold, which is meant to be a 10K. Yeah, we didn't seem to have anything else on the output of this. The input signal, the signal went in here, and then we had nothing on the output of it. So I'm just gonna, I don't know, maybe I should pull this 072C and just replace that anyway, just for shits and giggles. Because it's possible that that's pulling the signal down, hey? So let's just remove that for shits and giggles, because there's obviously something on this board is killing op amps. It's killing our 4.7s over here. It's killing our 7.4s. It's killing our level shifter. So I'm going to lift that and remove that from the board for a moment, okay? And now what I want to do is I want to see whether we have audio signal going to one of the pins of this 072C, okay? So, okay, let's power her up and let's see what we have. Should have audio signal here going in at this point here. Shit, I got nothing. Okay, now I've got no audio signal whatsoever anywhere. I also don't seem to have any audio signal on my... Hey? I don't have any audio signal on my frequency generator. What the fuck? Oh, it might be because I grabbed the wrong... Did I... Oh, I grabbed the wrong oscilloscope probe. My bad. That's my bad. I was using the wrong oscilloscope probe then. Whew. Whew. Goodness me. Goodness me. Okay, let's try it again. Okay, yes, audio signal there. Audio signal here. Audio signal after the resistor, yes. Audio signal after the resistor. Audio signal into one of the inputs. Input 1 of the op-amp. Okay, excelente. Input 1 of the op-amp. So maybe this TL74C was dead, and maybe it was pulling the signal down to ground. So let's replace this 072C then. Let's see, do I have a spare 072C? I think I do. I think this one's a brand new one as well. That's a 071. I don't know if that matters, but I won't use it just in case. No, actually no, the 071 is a different type, isn't it? Do I have any 072Cs? I have loads of them on donor boards, so worst case I can just take one from my donor board. 071. Might have to just grab one off a donor board real quick. Yep, I think it's donor board time. Let's find the donor board with the 072C on it. That has... Ah, here we go. Well, this board has loads of spare 074s. So that's good. If I ever need some spare 074s, if it keeps killing them, I've got loads on there. Let me just go and grab a spare 072. These are actually harder to find than I thought. I have less boards with 072s on them than I thought I did. Spare boards. Everything's either surface mount or 072s. Or 074s even. Here we go, might have one on here. On this one I have some NE5532s. I think NE5532 is compatible with the 072C. I think it's similar enough that I can get away with using it. Let's have a quick look. NE5532. Let's open that in a new tab. Paste and go. So the 072C is up here, yeah. So we just want to make sure it has the same pin out. Low noise operational amplifier. Out 1, in 1, minus, in 1, minus VCC, VCC to out 2. Yeah, okay, yeah, cool, it's exactly the same. So let's go ahead and nick one of these. There we go, that's out. David, you can use a 4558. Yeah, I couldn't find any 4558s either. I am used to seeing those though. I do have quite a lot of those usually laying around. Yeah, at the moment I only have surface mount versions of those. Okay, that's that removed. There's also another 072C over here, which is going to be part of the slave master circuit, the slave master preamp bit over here. That's probably fine, I imagine, I hope, possibly. Maybe not, but okay, so now we've replaced that. I want to see whether we now get audio on the input pin. I think it's the, what is it, the of the 072C. So this is going to be on the inverting input. So the inverting input is connected to the signal out of the filter board, I believe. Inverting input. Yep. So the inverting input is connected there to the. Okay. The strange thing is though is that we already had audio on the output. Yeah, you see that? Like even with this op amp removed, we had audio on the output, which is curious, you know. Yeah, we got just a few minutes. Yeah, I said I was capping this off at 2 AM. So if this doesn't work, then we'll continue with this another time. Okay, let's go. So we're going to probe before and after this resistor and see if we get audio anymore there. Okay, audio before the resistor. Okay, we don't get audio after the resistor still, so that 072C was probably fine. So yeah, I have fucking no idea. I have no idea. I have fucking no idea. How hot are 074Cs getting though? Because they're working at the moment. There's no DC on them at the moment. Okay, so obviously we've got a very big hot spot over here where we just finished soldering, so that's 40, that's 50 degrees over there. But our 074Cs, how hot are we getting over here? Nice and cool, 28 degrees Celsius, 29, 28. Although possibly starting to heat up a touch actually. 30 degrees, that's, you know, I wouldn't say that's too bad for an op amp. 30 degrees. 31. .33 degrees. They feel fine. So it goes into this op amp, except it doesn't. So the signal out from here, pin 5, goes over here into this 10k resistor. After the 10k resistor, it supposedly goes into this op amp with pin number 2, where we already have a sine wave on the output of this op amp, on out 1, which is really weird because that's the output. So why is there already a sine wave there? What I'm going to do next is the last thing I'm going to just try, just to see what happens this evening, is I'm going to plug the RCA instead into the slave input. We're going to have a look at the amplifier's case here, just to get a reference. So the slave input is the top one, and we're going to push this button in for slave input. And that's going to bypass all of this filter section, okay? It's going to bypass all of that nonsense there. So we're just going to get direct sine wave input through this op amp here, and it should send it straight to the driver card. So this is going to tell us about, a bit more about what the problem is here. If we get audio on the outputs now, then we know that the issue is somewhere in the main preamp section. If we still don't get audio, then it's a bit more complex than that. It's something stopping audio getting into the driver card completely. So yeah, let's turn the signal down and let's turn it on now and see what we get on the speaker terminal with the slave input run instead. Okay, we get audio, ladies and gentlemen. We get audio on the amplifier with the slave input used. Okay, so the main audio path to the driver board is fine. There's just something wrong with the main preamp circuit, filter circuit, etc. What's the model of the hat cam? I can tell you, actually, probably. Webcams, Logitech webcam, something 900. There we go. This is a Logitech webcam Pro 9000. They're all kind of around about the same model number. Swap the preamp board for the other Hertz. That's not a bad idea. We'll swap this board with the other maybe. Actually, something that somebody said in the live chat earlier. Actually, they might have a point. Okay. Now, somebody in the live chat earlier said, wouldn't there be 2 sets of outputs on the filter board here? Now, possibly. It depends how. So obviously on here we've got the RCA inputs and we've got the RCA outputs. Now normally the RCA outputs don't get filtered. Yeah, so the pre-in and pre-out are usually just clones of each other. They're very, very simple, pre-in, pre-out. Sometimes, however, the pre-out is actually after the filter circuit. So all of the settings that you apply to the amplifier, you end up with that on the pre-out, but I don't think that's the case here. If that was the case though, we would most likely have 2 outputs from the filter card here in the middle. But I don't think that's the case with these amplifiers. Interesting one. Let's just do a couple more quick experiments. I want to see whether we have any signal on the RCA outputs, on the main ones over here, and I also want to see if we just run the amplifier normally in master mode, whether we have any output on the slave output over here, because we would normally should have, right? Obviously. So let's just see what we have on the board in the RCA inputs and outputs. So let's turn her on. Yep, it comes on. Make sure that there's no turn the signal up a little bit here, get some RCA going. Yep, okay. So we've got some signal going on. So let's see, do we have any RCA output? Yes, we do. We do have RCA output on these RCAs. I can't get in there enough, but yep, there is signal on the RCA output just here. So that's cool. Now on the slave output, what do we have? Do we have anything on the slave output? Now I don't think I have. Let's just try and shove some tweezers in there or something. Here we go. I'll shove a Allen key in there. There we go. That'll do. That will get me some stuff. Okay, we don't actually have anything on the slave output. So maybe it's something to do with that circuit. There's nothing on the slave output, is there? And there's also nothing on this top one. Huh. Oh, that's because we've only got one. Okay, yeah, that makes sense. Okay. So there's actually no slave output. So whatever's preventing the signal getting to the output circuit is also preventing the signal getting to the slave output, the master output there on the RCAs. But this is still fucking confusing me. Why do we have? Why is the RCA? Why is the signal disappearing here? I'm going to check resistance to ground here. So the signal should be coming into this op amp here, okay, on pin number 2. Do we have any low resistance to ground on here? Ah, hang on a minute. Oh no, that's now climbing. No. No, so there's no low resistance there. Pin 3 is grounded, but I think that's probably just normal because that's the you always ground one of the inputs that you're not using. But what is very strange is that we, even with this op amp removed, we still had RCA signal on the output, but nothing on the input. All right, okay, let's continue following it then. Just real quick before we leave this evening, let's continue following. Where does the output of this go? Because we still have RCA, we still have signal output on the output of here. I don't think we had anything on the other side. So where does this go now? The output of that 072C that was originally there, where does that go to now? Did you click the switch, Bevids? Yeah, but regardless of whether the switch is clicked or not, you should still have it there. Because so with this amplifier in master mode, which I clicked the switch for master mode, there should be output on this terminal here. So let's follow then. Where does this go after the output of the op amp? So op amp is here. So pin 1 is this going to end up being this top one. So here, output of pin 1, we have, it goes to a bunch of places. We've got 2 resistors coming off here, this top one and this bottom one. It then goes to the other side of the op amp. Okay, so this resistor brings it round to the other side of the op amp into one of the other inputs of the op amp over here. Pin number 1, 2, 3. No, hang on a minute. Wait a sec. No, it's grounded. Okay, I think is that right? That ground. Yeah, that brings it round to... Oh, okay, that actually makes sense. That makes sense. I understand now why we have some slight signal on pin 1, the output, when there's no chip, when there's no op amp in. Because if you see here, pin number 2 has a little loop around to pin 1 through this resistor. Okay, So that's like going to be some kind of little loop. I don't know. I don't fucking know what this shit does. So then we come out of pin 1 and we go to this resistor. Then we go over here. And then it carries on through the board over this way. Okay, so let's trace that then on the top. Move that for a sec. So here we come out of pin 1. We come out of pin 1. We go into oh, what one was it? Fuck's sake. I think it was this one here. We go into R24M. Okay, we go into R24M. We then come out of R24M, and that resistance is a, what do we have? 670 ohms. 670 ohms out of 24M. Then we go into 28M directly, I think. Yep, directly into 28M. Then out of 28M, we then go into R31M. 28M is brown, black, yellow, gold, which I think is that's 100k, isn't it? Nope, wait a minute. Brown, black, yellow, gold. That's supposed to be 10 something, but that was reading 22 something. Hang on a minute. Maybe that resistor's open. Just remind myself what the multiplier for yellow is. Brown, black, yellow, gold. That should be 100k. Now we're reading lower than 100k. We're reading lower than 100k, which is good. That probably means that's okay, but fucking hell, that's a massive resistance, isn't it? That's a massive resistance. We're reading 24 across that. And then we go into another 100k, R31M, into a capacitor. And then are we finally then starting to make our way over to the driver board? Right, let's follow that with signal. Let's see if signal follows that as the multimeter does. Let's see if signal follows that as the multimeter does, shall we? Okay, turn the amplifier on. Signal going in, yup. Amplifier come on. Signal here, yup. Output switching has begun. No DC. Okay, so output of the op amp, yes. Into this resistor, yes. Signal out, yes. Over to this side, yes, signal. This side, aha, no signal. So, it's not making its way through the 100 kilo ohm resistor. Yeah, so there's no signal on the other side of the 100 kilo ohm resistor. Is there supposed to be? I don't know. Let's take a look on the bottom of the board and let's see if this goes anywhere else. Also, let's check continuity to ground at this point here where the signal disappears. Aha! 48 ohms. We have ground. We have ground at this point, so that's why the signal disappears. Okay, but that maybe is supposed to be ground. Maybe that's supposed to be ground. So let's take a look on the bottom of the board. So at the start of this 100k, let's see if it's supposed to go anywhere else. So out of that at the top, we then go into this one, which goes there. We go into the, aha, okay, cool. So now we have somewhere else that the signal is supposed to go. We potentially have a capacitor here. Let's have a look. Yes, we have a capacitor. Okay, now then we need to check this capacitor. We need to follow the signal. The signal goes into this capacitor here. I'm just going to turn my head down a little bit so you can see. So the signal goes into this capacitor here and is supposed to come out the other side of the capacitor. Let's check to see whether it does. But first of all, let's just trace it a little bit further after the capacitor. So after that capacitor, the signal then goes a bunch of places. We've got, this is empty, this pin here. So we've got a couple of components over here. So we go 1, 2, 3. So there's 3 traces there that the signal goes to. looks like we have this R92M potentially is one of the places that it might go. So let's just double check that from the top. So it's coming out of this capacitor here, and then we're going into a couple of places potentially. If the board had transistors here, it would go into one of these transistors. R29M and also C18M, which is not present. So we should have signal at the start of R29M and after R29M. What resistance is R29M? 22K. Okay, awesome. So we should have signal going there. After the R29M, which is a 22K, let's see where it goes after that. It then goes, there's a bunch of places it could go. That looks like it just fucking goes to ground again. I'm sorry, what? So the other side of R20, the other side of that 22K is just fucking ground. Why? Maybe that's a problem. Maybe that shouldn't be ground. Should that be ground? Trace there. There's another trace at the top of our... Hang on a minute, what the fuck? There's traces at the top and bottom of R32M. Trace at the top goes somewhere. Trace at the bottom goes also somewhere. Looks like... R29M, sorry, R29M. Bottom of that trace... Yeah, it looks like it just... Why the fuck does that go to ground? I can't seem to follow where the signal fucking goes. It doesn't go anywhere. Right, I'm going to turn it on again. I'm going to see if I can follow the signal through this capacitor just to see if it makes it through there. So yeah, we're coming out of this TL074C. Let's just plug this back in. Okay, filter board's back in. So let's go. Follow the signal. Remote wire. Signal at the start of the capacitor, which is cool. Signal at the end of the capacitor. Signal into R29M, and nothing after R29M. Okay. What the fuck? So R29M is just grounding the signal, and that's the only place it can go. So maybe that's not supposed to be grounding it. Oh, for fuck's sakes! We've got DC on the fucking signal again now. Now, I think now it's the other op amp. I think now it's the other TL04C that's died. They're not heating up though. I'm just gonna keep them in the board for now and just keep following this signal. So this capacitor, this obviously will block DC. That's fine. So, is the other side of R29M supposed to be ground? I do not quite know. Let's follow where that goes then. R29M. On the other side of R29M, we have what looks like quite a big trace, which I would imagine would be possibly ground. So that only goes to here. Then we have another small component there, which is R32M. So is R32M open or shorted? Sorry. No. So that's going to be ground on one side. The thing that makes me wonder, the thing that makes me think that it should be ground, is the fact that we have a capacitor here. That the C18M is a capacitor here, which is in parallel with R29M. It's not in the board, but it's in parallel with it. So a capacitor would usually have one leg to ground, which is what R29M is doing. You know what? I think the thing is to get the other Hertz amplifier out and hope that one makes audio. And then use that one to decipher what the fuck's going on with this one. Because I am done at this point in the evening. It's like 20 past 2 AM. I am done for now. I am done for now on this one. But we'll come back tomorrow with the other Hertz. And we will use the other one, hopefully, hasn't got the same issue, to figure out what the bloody hell this is supposed to be. Can you start at the driver board and work backwards? Maybe, but I don't know which pin of the driver board is supposed to be audio input yet. We've got a dual let's see if Perry's Guide has anything on these, but I don't think these are a really small driver board, and I think they're unique to Hertz. I think it's only Hertz that are using these really small one here. So I don't know for sure which pin is supposed to be audio input. Alright guys, so we're going to lock it off this evening, and yeah, lock it off this evening, and we're going to get the other amp tomorrow evening. So jump on the stream tomorrow evening, hopefully about 9 or 10 PM UK time, same sort of time as this evening was. Hopefully the other amplifier will give us the key to what the hell is going on with this amplifier. But what is still concerning me is why these TL074Cs are still dying. Even if we get good audio, I don't know whether that will solve that problem. I have quite a lot of spare 074Cs on donor boards, so we can work our way through them. And when we finally get audio to this amplifier, as we should, we'll monitor it and see if it keeps killing these 074Cs. If it does, then I don't really know what to suggest. It's a very strange one. Yep, guys, once again, thanks very much for tuning in. Have a good night, and I'll see you guys tomorrow. Take it easy, guys. It's been a pleasure.